All
right, good morning everybody. Welcome to SCaLE 22. You're here in the Postgres room. We are lucky to have Magnus Hagender here, who's going to talk PostgreSQL 18 and a look at the elephant's trunk.
Thank you. Yeah, good morning everyone who braved this very early morning for the first talk of the conference, right? I do like it with SCaLE where they start really early at 10. It's a good time to start. It's an extra good time to start for those of us who travel in from afar to get here. As said, my name is Magnus Hagender. You're hopefully here to listen to something about Postgres. If not, you misread the schedule and went to the wrong room. My name is, as I said, Magnus Hagender. I work for a company called Red Pill Linpro. We're an open source services and consultancy business based in Scandinavia. So we're in Sweden, Norway, and Denmark. I'm out of Stockholm in Sweden myself. Thus, starting at 10 a.m. the first day after you arrive is very nice. So I lead up our database offerings that are based primarily around Postgres. We do a whole bunch of other things, but I try to stick to the database side as much as I can. Within the Postgres project, I'm one of the Postgres core team members, the steering committee for the project. I'm one of the committers on the code base, though I don't do as much as I'd like to because too many other things to do. And finally, I'm also serving on the board of Postgres Europe, which does sort of similar things to this, but in Europe. The schedule here for the Postgres day, or the Postgres track, I should say, through 2 days here is managed by Postgres US, which is our US sister organization. But I'm always happy to come over here and talk to you guys as well. So enough about me. Let's talk about Postgres. Who is already using Postgres 18? Okay, that's good. That's good. It doesn't exist. So that's good. Who's using Postgres 17 today in production use, is what we're saying. Okay. See, 16. Oh, it's pretty good. 15. 14. Getting there. Okay. 13. 12. Okay. You guys have a job to do, right? You're aware that 12 is end of life, I'm sure. So you're already in this panic state of trying to upgrade. What about versions older than that in production? Oh, that's fun. What about versions that had a single digit as their first number, starting with a 9? See, don't run those in productions anymore. Please don't. I mean, they work, right? But they're very far from being supported. So, no, we're going to talk about Postgres 18, which is then the upcoming version of Postgres that, again, does not exist yet. Maybe don't run it in production just yet. If you want to run it in testing, by all means, please do. But it's a little early to run it in production so far. So looking a little bit at the development schedule to get us to where we are, or where we're with Postgres 18. So those of you who've seen me do these talks before about the new versions will recognize this thing. This year, I remembered to replace the years. Last year when I gave this presentation, I think it was here in Pasadena, I forgot to replace the years and just replaced the version numbers. But we've stuck to a pretty strict scheduling for many releases of Postgres now, which is we started what will become Postgres 18 basically in July of last year. And the way that we do this in Postgres is we do all of our feature developments on the main branch, and then we have release branches. So what happened in July was that we created the branch release 17 stable, and that's what then in September became released as Postgres version 17. That's just a general, software development tip, right? If you're having trouble stabilizing your code to be ready for release, just create a branch called stable, and now your code is stable. It's very easy, it works great. But what it means in the form of Postgres development, so at that point we separate out 17, all work goes into stabilizing it and getting it released, but it also means that the main branch gets opened up for new feature development then into what becomes 18. And in Postgres we use something we call commit fests. It's just our way of doing iterative development. Everybody has their own little terms. The idea here is that we spend a month building features, and then we spend a month reviewing and committing those features. there's a lot of arguments on whether how well we actually stick to this process, but that's the general idea. And then, of course, at the end of one of these commit fests, the idea is anything that's not ready gets thrown out, and then we start the cycle over again. So we've run so far 4 completed commit fests. July, September, November of last year, we ran one in January. And then the 5th and final commit fest for Postgres 18 started in March, which is, a couple of days ago. So it's currently in progress. It has barely gotten started. So what that means is we're pretty far from what is Postgres 18. Now, there's a general rule, guideline, what we want to call it, that nothing completely new can get put into the final commit fest if it's anything but very small. But there are a lot of fairly large things that have been reviewed and gone through this cycle many times that are still in the queue. And they may very well make it into what will become Postgres 18. And likewise also things that are in Postgres 18 now may go away. Something was reverted just yesterday, I think. Luckily, it was not something that I had put on my slides, so I didn't have to update them. But these things happen all the time. So the things that I'm going to go through some of the things that I've found so far that I think you would be interested in version 18. It's not a guarantee they'll still be there when the release comes. And even more so, there will be many more things that aren't in there yet. But we still have a pretty solid set of features that are coming out for 18. So an almost truth, so I'm saying the current status of what it looked like. This is actually the status on, I think it was Sunday. We had 1,810 new commits into Postgres. Now, Postgres still here applies a methodology similar to sort of how we work with commits and things, is similar to how we used to work with things when we did things in like CVS and these. So really a Postgres commit would be the equivalent in most cases of a git merge, right? We basically do consider them git squash merges of the features. So that's 1,810 individual merges is the equivalent. So you can't really compare commit counts. As you can tell, that's quite a lot for half a year, or a little bit over half a year. We've had some 3,500 files modified, 150,000 new lines of code, 73,000 deleted. Also, obviously, these numbers are going to go up. They don't really tell you much other than there's a lot of stuff that's already in what will become Postgres 18. So let's talk a little bit about the features that we've added. I usually group these into 4 groups. I'm going to talk a little bit about DBA and admin. I'm going to talk about SQL and developer. I'm going to talk about backup and replication. And then, of course, everyone's favorite, performance. Right? Today, I'll say this list is a little bit skewed so far to where like some sections of these are very small. I think they will actually end up evening out more when I look at what's in the queue for 18. But we'll see about those. So let's start with the important stuff, right? What's going to break? There's always a couple of breaking changes. They aren't major. When we look on the building side, most of the breaking changes that we're seeing so far now, I think, are going to be on building sides. For example, we have removed support for the HPPA risk architecture. Anyone using that? Anyone ever used that? Like there aren't any people quite that old, right? That's not true. HPPA has been around for a while because those machines just didn't die. But this is not going to affect you. Likewise, Postgres has removed support for building without spin locks and atomics. Like we've had these things in our CPUs for at least, I don't know, in even the cheapest CPUs for 30 years now, I think. This is not going to affect you. These are just sort of cleanup processes. The thing that might affect some people is that Postgres dropped support for OpenSSL older than 1.1.1. If you are stuck in an environment where you have to build Postgres for really old versions of your operating system, this can become a problem. But maybe you should consider if you're really going to run, the latest and greatest Postgres on a 20-year-old operating system. This is kind of an unusual combination, but if you do have that combination, you may run into trouble with that one. I think this is really today the only big breaking change. So for those of you who've been with us for many years through many upgrades, this is an unusually short list. There is usually something else that will break one way or another. Most of the things that breaks are things you weren't supposed to do in the first place, but if you did them, it still broke. Okay, let's talk about the things that are actually useful. Let's talk about things that are being added. I'm going to start by a change, which is actually a feature. It's a changed default that I personally very strongly believe in. Postgres will now enable page level checksums by default. We've had page level checksums since I think Postgres 9.1, or was it even 8.1, like ages and ages ago, but they have not been enabled by default. So you had to remember to turn them on. Did you? Probably not. As somebody who works, as a consultant, I work with a lot of different customer systems. I think I've so far come across like 1 or 2 customers who actually enabled it. And then you explain to them what they do, and they were like, why didn't we enable that? And that's a good question. So it will now be enabled by default. If you don't need it, if you don't want it, you can still turn it off. You give in a DB the no data checksums. You're back to what it was before, but you probably want them. And one big difference is you can change. Like if you've installed the system, you've initialized your database with checksums, it's really cheap and simple to turn it off. You stop your system, you have to stop it, and then you say PG checksums disable or whatever it is. It turns it off, it takes less than a second, you start it up again, you're good to go. To turn them on an existing system, you have to rewrite the whole database. There's still a tool that will do it for you, but you're looking at non-trivial downtime if your database is of any size. So the default is better. The other thing to remember, this does not affect you if you upgrade. Right? If you upgrade from a previous version using PG upgrade, if you didn't have checksums in 17 or 16 or wherever you're upgrading from, you will also not have checksums in 18. So the default only comes on new installs. If you're upgrading using PG dump and PG reload, or if you're upgrading using logical replication, then the new default will apply because you have an actually new cluster, not an upgraded cluster from the database perspective. But if you're just doing it in a DB, you will now have data checksums. And speaking of upgrades, another thing that I think is going to help a lot of people around upgrades is that Postgres will now transfer statistics on PG upgrade. Now, first of all, you've got to think of, there are 2 things here. We have Postgres has PG stats and PG stat, just to confuse you, right? PG stats are the optimizer statistics, right? The ones that we collect using analyze. The ones that tell you, the distribution of values, how much of your data is null, all of this data that the optimizer uses to build a good query plan. And then PG stat is the one that, PG stat user tables tells you, how many index searches you've had, all of these things. PG stat is not being upgraded. PG stats, your optimizer statistics are now transferred. Now, traditionally, when you do PG upgrade, the last step, it says, run this vacuum db -- analyze in stages, and then spend anything from a minute to 3 hours before your database is upgraded. And until you've done that, you get really terrible query plans. And particularly on large databases, this analyze in stages takes a lot of time to run. Postgres 18, you will not need this anymore. It will transfer the existing statistics from your system. You will be able to start it up immediately after the upgrade. So potentially, I would measure upgrade times can go from 4 hours, if you count this thing in, down to maybe 2 minutes. Like it's that kind of a difference if you have this need. So I think this is going to be a huge feature for those. Now, technically, this feature is actually in PG dump because PG upgrade uses PG dump. So you can use this if you are upgrading using a dump and reload as well. It's just usually if you're using a dump and reload to upgrade, this is not the part that takes the most time. It's the actual reload that takes the most time. But I think it's going to be a big improvement for that one. Then let's talk a couple of things around authentication. Who's using Trust for their database for all logins? Stop doing that. For many, many years, the gold standard in Postgres was to use MD5. MD5 is terrible. MD5 has now finally been officially deprecated. Right? MD5 is what we used to use for username password login. In Postgres version 10, we changed that to support SCRAM-based and SHA-256 authentication, which it's not just the change from MD5 to SHA-256 that makes it better. It's the whole SCRAM challenge response. The Postgres MD5 authentication has bigger problems than MD5. In fact, the MD5 part is not the biggest problem. It has a bunch of other issues, which is why it's been sort of soft deprecated for a long time. It is now hard deprecated. You will get your logs filled with warnings. Right? When you set a password using MD5, you'll get a warning. Right? You can turn these off, right? You can set MD5 password warnings to off if you absolutely have to. But don't. Fix your system instead. Use Scram for your password-based login. It's better, it's strictly better in every possible way. There are no drawbacks. When Postgres 10 came out with it, there were drawbacks because you, for example, couldn't use older versions of the client. You couldn't use older versions of the Java driver or things like that. But Postgres 10 is 8 years ago. Right? Postgres 10, 11, and the 12 are unsupported at this time. If you're still running that version of your client drivers, you really need to update your client drivers. And then the problem goes away. So yeah, MD5 finally officially deprecated. We're getting rid of it. If you want to dig into some more complicated authentication, Postgres 18 will support OAuth bearer tokens for authentication. Now today, this is kind of useful to a level, but to really use it, you have to write a server-side provider, right? Because it has to know what to do with this OAuth data. There is no such provider that ships internally in Postgres, but we would kind of expect that the early implementations of these are probably going to be people like Azure and AWS, who will then build an OAuth bearer authentication that plugs into their existing infrastructure for user authentication. But OAuth, as you know, it's an open protocol. A lot of things can be done here. I would expect we will also, over time, hopefully pretty soon, see some generic OAuth plugins to run on the server side to integrate with, other well-known systems out there. And we've also added the ability to do Scram pass-through authentication if you're using Postgres foreign data wrapper. That is, if you're using today, right, if you're logging into a Postgres and then you have a foreign table using Postgres FDW that sits in a different database, you have to create a user mapping in your first Postgres server that contains the password in clear text. It's protected, but it's in clear text, of the user that you're going to connect to at the other server. Now with Scram pass-through, you don't have to do that. You can turn on Scram pass-through on the first server, and then if I log into the first server, that one is able to use my credentials to pass through to the second server. And as long as I have the same Scram identifier, which means I have to have the same salt and iteration count, so you can't have different Scram configurations, but as long as you have those, you get a pass-through authentication to the next server. So for example, if you're using this to do sharding or something where you have some tables on different servers and stuff, it works similar to Kerberos delegation, if you've been using that for Kerberos-based logins, but for Scram-based passwords. So yet another reason to switch to Scram, not just to get rid of your MD5 warnings. These are all good. If you're using TLS, Postgres had a bunch of configuration things that just didn't go all the way. We've supported TLS 1.3 for a long time, but when you configured explicit cipher suites, you couldn't choose the ones that are in TLS 1.3. Well, now you can. If you're using TLS 1.3, you can, since before you can configure your system for like a minimum usage, a minimum version to be 1.3, for example. We now also support multiple versions of the ECDH curves. If you have specific crypto requirements, where your people are saying, well, these are the only ones that are approved, in my environment, I have to use these. You can now lock these in. And speaking of crypto, I mean, this one also comes out nice. Like, you can now disable the crypto in PG Crypto. You're like, okay, well, what's left if we disable the crypto in PG Crypto? Well, PG Crypto, right? It has hashes, it has simple encryption, it's PGP support, and a few things like that. It both has a built-in version, and then it can run on top of OpenSSL. And the reason you want to turn this off is if you're in a FIPS environment where FIPS puts requirements on which crypto is available at all. Even if you use it or not, it cannot be available. If you turn this off in PG Crypto, it will fall back to only have the OpenSSL versions, and then you have an OpenSSL build that is FIPS certified. Now PG Crypto becomes okay for FIPS. So it's mostly a compliance thing, but there is a bunch of things left. Then, I said we were in the section of DBA and administration, so luckily we have, some more things about vacuum. We all love vacuum, right? There are a couple of I think, really useful things to improve our handling of vacuum, there are also a few things on the performance section, but in the admin side, we have a new configuration parameter called auto vacuum max threshold, because auto vacuum was too easy to configure, so we had to add another parameter. the idea, right? So the simple ways of how auto vacuum works, and it calculates a number that is the number of rows in the table times auto vacuum scale factor plus auto vacuum threshold, right? And it gets that number and it says when this many rows in the table are dead, so modified or deleted, then we run vacuum, right? That's the simple case to it. And the default value here is 20% and 50 rows. So when 20% of your table has been updated or deleted, plus 50 rows, then we run the vacuum. Now, if your table has 10 billion rows in it, how much is 20%? Too much, right? So how do we deal with this today? Well, we do things like some people run vacuum manually, sometimes you do an alter table and you set this percentage to a much lower value. So we're giving you a new way here. Auto vacuum max threshold, you can, for example, set it to 20 million, or the default is 100 million. That says if this value calculated by 20% of your number of rows gets above this, we use this value instead. So for your 10 billion row table, it will now start vacuuming at 100 million instead, because that's sooner. And you can set this much lower if you want. So question is this a table only or overall? So there is a Postgres, you set it in postgres.conf globally, but you can also set it on the individual table with alter table set. So you can control this very carefully in these areas. And the 100 million default is kind of, I don't think you're ever going to increase it. It's already starting at a pretty high number. I think we're going to see a lot more cases where people want to decrease this to vacuum more frequently. Because I think that's, and again, seeing what I see when I go out and talk to different customers, it's a much more common problem that people, when they have problems with vacuum, they try to vacuum less. But the solution usually is to vacuum more. And this will help you find that balance more. You can now change auto vacuum max workers without restarting Postgres, which is great. Of course, to do this, we created a new parameter called auto vacuum worker slots, which you cannot change without restarting Postgres. It's still helpful, right? Because changing auto vacuum max workers, that's a tuning function, right? You might need to change this. Whereas auto vacuum worker slots, the cost of having a high value in auto vacuum worker slots, like 20 instead of 3, is not that big. And then you can even dynamically, or at least manually, tune this auto vacuum max workers within this window, so up to this number. So we didn't magically remove the problem, we just basically split the parameter in two and made one of them much cheaper and easier to tune. So that's max, right? That's max. This is the max worker, yeah. The vacuum command and the analyze command have gained the only option, which forces it to not recurse into partitions, for example, or recurse into table inheritance, but nobody really uses table inheritance, I hope, other than partitioning. The idea here is if you run vacuum, like a partition table in Postgres has this little fake table that has no data in it, and then it has all the partitions under it. But if you run analyze in particular, on the root table, it will analyze the subpartitions. And you may not want to do that if you have many subpartitions, but previously there was no way to actually do this on the root table without recursing into all the partitions. Now you can say only, just like Postgres already had like select only, that would select only from this table. Explain analyze. It's been enhanced with some more information. Buffers is now enabled by default, so you don't have to type that anymore. I think that's from all of us typing it every single time, and we're like, can we stop typing this now, please? And got that fixed. It will show much more statistics about parallel bitmap scans. It'll actually show what happened in the different parallel sessions. It'll show how much memory and disk was used for materializing nodes. Previously, it would just say, oh, I materialized this here. And it never told you what the cost was. So basically, the explain analyze default output will contain more information, and the verbose output even more beyond that. So further data in there. The copy command has gained another log level. Hopefully, you're all aware of the fact that since a few years now, you've been able to do copy from, and you can say on error ignore. And then it would say, copy it and say 2 rows were skipped due to data incompatible. Like I tried to load a string into an integer field or something. And you could set log verbosity to verbose, at which point it would log every row that failed. But you couldn't actually get it to shut up. Well, now you can get it to shut up. Log verbosity equals silent. Just runs the same thing, but ignores those rows without telling you about it. Yeah, I love statistics. Sorry?
Question about copy. So will it have the same effect when you do file foreign data wrapper because it uses copy under?
So the question is, will it have the same effect if you use the file foreign data wrapper? Yes, I believe this option is also available for the file foreign data wrapper. So yeah, as someone who often also has to deal with tuning other people's system, statistics is great. Like now we are talking about the PGStat system that tells you what's going on, right? And there are a bunch of new really useful statistics that are coming to you to let you see how your system operates. Parallel workers, we have 2 new fields. I love the names of these, right? Parallel workers to launch and parallel workers launched, right? Both these fields are added to both PGStat database and PGStat statements. This will help you tune your parallel query, hopefully, right? Because it basically says, you have the max parallel worker processes, tells you how many parallel workers are allowed in the system. If they're always enough, then these 2 numbers will be the same. But if you see that it's a higher number of parallel workers to launch than parallel workers launched, that means Postgres made a query plan and said, hey, I could use 3 extra processes or 3 extra CPU cores to run this query, but they were not available. Right? Maybe it's a fact of life, but maybe it isn't, and you could actually tune the system to let this query use more processes, thereby running faster. And again, you can see it grouped by database in PGStat database, and of course you can then sum it across PGStat database and get the global stats. And you can view it for an individual query in PGStat statements, because everybody's using PGStat statements, right? Is anyone not using PGStat statements? I'm glad nobody puts their hand up. I think that's the first time that everyone's using PGStat statements. Finally. So we have some vacuum stats in PGStat all tables. So for both your tables and the system tables, you now have total vacuum time, total auto vacuum time, total analyze time, and total auto analyze time. So it just tells you of these 125 auto vacuums that have run on this table, how much time did it take in total? And then you can divide it by the number and you get the average time, right? Added on a per table basis. We also have something interesting in PGStat progress vacuum and PGStat progress analyze. We now get timers for how much time was spent delaying. Right? So, vacuum in particular, auto vacuum has this cost-based delay where it intentionally slows itself down to not overload the rest of the system. These numbers will help you figure out how much of the time was actually spent slowing, like how much time has it spent slowing itself down. Now, there are discussions right now going about sort of adding some stats that actually show us both of these, because right now this data is only available in these progress views, and as soon as your vacuum finishes, this goes away. So if that might not make it into this version, but at some point it should hopefully be sort of merged and available along with this stuff. Our write-ahead log stats are now tracked in PGStat IO. A couple of versions ago, we gained this new, more granular IO view that tells you, divided by backend types and stuff, like where's your IO coming from. The while IO has now also been merged in there, so you can see, you still have the global stats in PGStat while for some of it, but the actual IO is moved. You used to have a global value. Now you can see how much of the while is generated by the checkpointer, how much is generated by normal processes, how much is generated by auto vacuum. Like this type of split up is now available, so more details. And also the flag for wall buffers full, or the counter for wall buffers full, like how many times did you run out of the memory buffers for your wall, has now been added to PGStat statements. So you can see it per query, where this has happened, not just, oh, it happened, I wonder why. It's been added to vacuum analyze in verbose mode for this particular one. Did we run out? And it's been added to explain if you add the wall parameter or wall flag to it, you get that. Then again, we still have the global value as well. So lots more interesting statistics coming up. Okay, let's move on and talk a little bit about SQL and developer side of things. What do we have here? What do we have for you who are developers? Well, Postgres 18 will add support for UUID version 7. I still personally think this is really weird because UUID has like 7 versions. Actually, it's 8 versions, and it's exactly the same UUID. There's no difference in the UUID. It's only different in how you generate it. So it's really the generation function version 7. Primarily, Postgres had a bunch, but primarily what you've used, and if you just say PG random UUID, you get UUID version 4, which is a completely randomized 128-bit number written with weird dashes in it. What UUID v7 does is it takes a part of this and says, actually, this part is sequential, and the rest is random. So the default says that the first parts of it will be the millisecond, like the epoch counter in milliseconds, basically. Then there is a 12-bit implementation defined, and then the rest is random. Postgres has defined this 12-bit to be sub-millisecond timing, so that you will have more than the standard level of sequentiality. And also, if you generate multiple UUIDs in the same session, they will always be sequential to an extra 12 bits. So as you can see, example here, I've just selected UUID v7. You'll notice the beginning is the same for all of them. If you actually used UUID v4 or the generate random UUID, they would be completely random. So why is this good? Well, this is good in a couple of ways. One big thing in Postgres is indexes, right? You get a massive write explosion if your data is completely random, and your indexes get much happier if you're sort of sequentially. So the idea here is they are still random. They're just not 128 bits of randomness. There is, for most use cases, still by far enough randomness, but then you get the beginning of it to be sequential, which means the indexes are going to be much happier. You can also, there is a function that you can take one of these UUIDs and pass in, and it can extract the timestamp. So you can actually see when this UUID was created. That's part of UUID v7. So I think this one's going to be really useful. One thing that I know I'm really going to like is the ability to use old and new for returning. You know, when you do an insert, an update, or a delete in Postgres, you can say returning. But this one will now let you return old or new. So in this case, you know, update set a equals to returning the old and the new value for this one. Same thing if you do an insert, of course, then the old value is going to be null because there was no previous value when you did an insert. When you do a delete, the new value is going to be null because there was no new value at that point, right? So this lets you inspect both the old and the new instead of first having to query it and then doing an update, right? So that's really useful. But one thing that I think this is going to be even more useful for is it works with insert on conflict. So you can now determine whether your insert on conflict actually generated an insert or an update, right? The idea is we do something like here, you know, insert into T the new values, on conflict instead update the counter. Right? This is a pretty classic one, and traditionally you wouldn't really know whether it updated or not. You can get all the data, but here you can see that the first one generated null 1 for, you know, old new, and then it generates values. So by looking at this value, whether it was null or not before, you will actually know whether this value existed when you insert it. And I found that to be a fairly common thing when I look through applications where, oh, I would love to use insert or on conflict because it's much faster, but I have to actually know whether I created an object or not. So I have to select and check it first, and now I've lost the whole point of insert on conflict. So I think this is going to be really useful for a lot of such applications to know that part. We've added support for virtual generated columns. So, you know, it's just like stored virtual columns, except they're not stored. They're recalculated on each read. The biggest difference between stored is, of course, well, it's not stored, so it doesn't take up space, but you also can't index it. But it gives you an interesting option to create sort of a hybrid between a table and a view, because you can create a table, and then you can add a couple of columns that are really more like a view without having to create a full view. So you create it, it just looks like this. You know, this one here, the generated always as, stored is what we had before, and you just remove the store part, and then it becomes virtual. You can also say virtual. And on this table, every time you query it, it's going to recalculate A plus B and return that as the value C. Obviously, if you just want A plus B, probably not the most important thing. But stored virtual columns really useful for things like text search, where you need to index it. But virtual columns, there are a lot of good use cases for them as well, because they're a lot cheaper since you're not having to store it. And on the topic of additions to tables, we have once again added temporal keys to Postgres. Now, if you were here and saw me do this presentation about Postgres 16, this exact slide was in there. Not entirely true, I've changed one thing in the slide, but that was more of a typo kind of thing. Because we had this in Postgres 17, and it was one of the features that got reverted because there were problems with it. Those problems have now been fixed. Hopefully nobody will find new problems, and we will have them again. So what does this really mean? Well, we've got temporal primary and foreign keys. Postgres more or less had temporal primary keys already. They just weren't called temporal primary keys, and they didn't follow the SQL standard. The idea here is we can say we have an integer, which is our traditional primary key. We have a date range that says when this integer is valid. And then we say, actually, the primary key is of the ID and the range without overlaps. Now, when you did this manually in Postgres before, you would key. The primary key would only work on equality. But we could do it, right? That worked. It's now in the standard. It's now easier to use. The foreign key thing here is you can actually have a foreign key that then includes, and then you have to use the magic word period, which is kind of interesting because Postgres doesn't have period, but it maps it to any Postgres range type. So this works for any range type. Using something like a date range or a timestamp with time zone range is going to be the most common use case, but it works with any range type. And then it says, it references this other table, which also has these two columns, and then it just has to, like it does an overlaps check on the range and an equality check on the ID. And I think the typical use case in this is going to be you're going to have your ID, which is going to be a big int or an int, and a valid range. And then you can look at your database, historical data, it's still all there, almost like the old time travel function, except it's in user space and you can control which tables need it. But the thing that's tricky to do with that today is you can't get a foreign key that works properly, basically, today. And with this you can. So the enhancements, it's in the foreign keys. Now, in practice, you are almost always going to want to install this b3gist module, right? b3gist is in Postgres contrib, it's right in there. But if you don't, then this ID would also have to be something that's gist indexable like a range. But normally your ID is going to be an integer. And for that to work, you need b3gist. So the question is this for application time only or for system time as well? So these are two concepts in the SQL standards, talk about this differently. This is fully user space, so this is application time. But it's a good foundation to build the rest. Okay, let's add one of those simples that I thought was going to mean nothing, and I had one of my colleagues say, finally. So there's now an array reverse function. You can reverse an array. It's surprisingly how useful that is when you really need it, right? But to me, it was like, yeah, sure, now we have it, yeah. Mm-hmm. But, some people really need it, and then, it can be your big feature this time. Okay, let's move over to talk about backup and replication, which to me, I think this is the shortest section of backup and replication I've had in many, many years. But there are some interesting things going on. Partially, I'd say one of the big things that went in is this statistics transfer for update, which technically is in pgdump, so that's really backups, but it's useful for upgrades. Small thing, PG verify backup can now verify your backups if they're in tar format. Previously, you had to have plain text backups to use PG verify backup. All right, useful. A bigger thing is you now have the ability to replicate generated columns with logical replication, right? Only stored, not virtual, that I just said were great, but stored replication. So previously, if you had a generated column, you had logical replication of the table, it would not be replicated because the assumption was you had exactly the same table on the other side, so there would already be a generated column there, and you could just regenerate the column on the other side, and that would make sense. But there are a bunch of cases where this might not be the case. You might actually be replicating into a table that does not look exactly the same. It might have a slightly other format. Like as long as it's compatible, logical replication works. You might be replicating into something that is not even Postgres. So what you can do now is you can, when you create your publication, you can specify with publish generated columns, and it will just publish them. And also, if you don't set it on, and then it will do it for all of them, right? You can also, when you create the publication for an individual table or add an individual table, if you specify one of these columns, this is the same test table I had before, A, B, C, D, where D was a generated column. If you include a generated column explicitly in the column list, it will also get replicated.
Does it make a difference if it's virtual or stored?
Does it make a difference if virtual or stored? Yes, because it only works if it's stored. If it's virtual, you will get an error message. It is right there on the screen. Lucky me. I didn't have to say, I don't know. Because again, a lot of these are very new features. Some of them I've only tested just to make these slides. Some of them I've tested for more things as well. We have a new view called PG Stats, subscription stats, that generates or collects conflict stats on the receiving side, on the subscription side. Say, how many times did you replicate an insert, and we couldn't insert it because there was some other data in the way, because you did wrong. Saying update conflicts, origin conflicts. When did you replicate an update and the row that was supposed to be updated didn't exist? Like these are the classics. If you're just having a straight over logical replication, identical tables, nothing should be different, then all of these should be 0. Good to look over. But sometimes we do intentionally replicate parts of our data. We may replicate from 3 different sources into 1 destination. Conflicts can happen. Here's how we track them. As I said, an unusually short part on backups. Let's take a look at performance. As always, there's a lot of things. I went through, I make all my notes when I make these slides. I go through the commit logs, and I go there's a lot of stuff here about performance that I had no chance of explaining in a presentation. At least not in a presentation that's only 45 minutes, right? A lot of them are not directly exposed, as in things will just run faster, and you will just be like, oh, it's faster, thank you. Right? They're non-tunables and they're non-visible. So I'm focusing here on a bunch of the things that are visible. There have been some, and there is still a lot of interesting ongoing work to make vacuum faster. One of them is that vacuum has been redone to use the streaming I/O interfaces in a lot of places, which just means it runs faster. But what you will notice is it will more eagerly, I love this, right? This tells things for everyone. It will more eagerly vacuum all visible pages. Okay, who actually understands what that means? Couple of people, not many, right? That's really the case, right? The idea is, so aggressive vacuum is this thing we do when we're about to hit XID wraparound. You've seen it, you may have seen it. If you've seen it, it was probably painful. Auto vacuum kicks in and removes all the delays and just runs quickly to keep your system up. You're already in trouble when this happens. The idea here is you can end up in a case where every row on a disk page is visible to everybody in the system. At that point, vacuum will stop vacuuming this page and wait until it hits this threshold for the XID wraparound, and then it will do what we call a freeze vacuum to mark it as frozen, right? And your problem is, if you have your 10 billion row table, and this happens to 75% of the table at once, it becomes really, really expensive. So the idea behind this change is to actually more frequently do these vacuums, and then try to heuristically figure out if it did this and it could freeze the whole page, mark the whole page as frozen, then it's a win. And if it couldn't, then it's a loss. And it tries to dynamically figure out how far to go to sort of amortize. And the idea is to make this aggressive vacuum cheaper when it hits. It's not going to go away, but it's going to hopefully, step by step getting so much cheaper that it doesn't matter. That's the goal. But what does it mean? It means you will see some more vacuums, even on tables that you didn't have anything change in. PG upgrade has a bunch of things now, more than before, that are parallelizable. So if you use PG upgrade with -J for multiple CPUs, multiple jobs, previously would just do the PG dump and the pure copy link, but it ran a whole bunch of queries, verifications, transferring of stuff that would run single-threaded. It will now parallelize. So this, in combination with transferring the stats, can make your upgrades a lot faster. So if you didn't use parallel PG upgrade before, if you have a large database, particularly one that has many objects in them, it's mostly many objects, not size of objects, like with all things about PG upgrade, take a look at it. It's probably going to help. We have a bunch of things that you might see that you don't have to do with as just general queries. For example, Postgres will now detect group by based on unique indexes. Right? Previously, if you did a group by on a primary key and something else, Postgres knew that, well, the something else doesn't matter. The primary key is there, right? And now it also looks at uniques, unique indexes, even if they're not the primary key. So you can see basically columns disappearing out of your group by queries because they were irrelevant. Postgres now has proper row estimate for generate series for numeric and timestamp. It previously did for integer, right? If you did an explain select star from generate series from 1 to 1,000, sorry, that's a bad example, from 1 to 5,000, Postgres would get that this is going to be 5,000 rows and optimize for it. If you did it for numeric from 1 to 5,000, Postgres would assume 1,000 rows. That's why 1,000 was a bad example. Same thing, if you put in 2 timestamps, it would assume it's always 1,000 rows. Now, if you are using generate series in your production queries as well, which is not that uncommon, actually having this estimate, because we can know this, right? We don't have to guess. For most of your queries, we have to guess how many rows it's going to return. For generate series, we know, it's math. We can calculate it, it's very simple. So they will just get better query plans. Recursive CTEs have been optimized, the tuple store. I've seen tests that show that recursive CTEs get up to 25% faster, which is pretty impressive because you didn't have to do anything. Right? These are recursive CTEs that do very little other than recurse. Nevertheless, 25%, it's always a good thing, right? Partition-wise join uses less memory. I still say this is one of those, it's a guy named David Rowley who wrote it, like he gets so much geek cred because he optimized JSON string escaping using hardware SIMD instructions. Because why not, right? So JSON string will be faster. Postgres can now run right-hand semi-hash joins, which might mean you will see your queries flip the order in a join from left to right if it thinks it's faster, depending on the size of the tables. Again, you don't have to do anything about it, but it might see your query plans change in a way like that. Numeric multiplication and division is faster if you're using numeric. It should really just be faster. Yeah, no, it changed the algorithms that it uses because these are numeric, right? It's the arbitrary precision numbers, right? So yeah, it changed the algorithms in a couple of different steps that just, yeah, it's just faster.
Because numeric is stored as strings?
Because, well, numeric is not stored as strings, but it's not like it's stored in a special magic format. It's not like you got float and you got integers, which are mapping to CPU operations, and the CPU will handle division and multiplication for us. But for numeric, they are so big we have to handle them in software, and there are different algorithms for doing this the fastest possible way. We have added, again, this has also added to Postgres 17 and removed again, the self-join elimination, which basically means if you're joining the same table into your query tree more than once, and the system can prove that this was not necessary, it will just remove it. So this, the simplest of all examples, here I'm querying from 2 tables, which both happens to be, T1 with 2 different aliases, and I'm joining it on the primary key. You don't need that join, right? So it just removes it and it scans just one of them. Now this, obviously you wouldn't write, I hope you wouldn't write a query like this. But number 1, you might have a query generator that writes a query like this for you. But also you might have views, right? And the same table is joined in 2 different views and then you're joining the 2 views, right? And there are a lot of cases where that's not necessary, but the system is now gaining the smarts to actually remove them. So we're hoping that it's better this time. Because it was in there before and it didn't hold. So again, beyond this, there are a lot of other things, performance-wise, as in almost every version, like things will just run faster. And also, commit fest 5, we just started. There are a lot more things in all of these categories that are in the pipeline to get into Postgres 18. Hopefully the things we've seen here, at least some of them are enough to make you excited about getting to upgrade to 18. Hopefully the release, as usual, is going to be out in the September to October timeframe. That's the goal. It's not a promise. Just like in all of these features are goals. They're not promises. Even what we have now, right? There are smaller fixes, performance improvements, yada, yada. We cannot go through all of them. So the final thing that I'm going to do is I'm going to ask you all to help out, right? We don't have a beta version yet. We would expect the beta version to come out sometime in the May timeframe typically, but you can already get, at least for APT, for Debian and Ubuntu, and for RPMs and YUMs for Fedora and Red Hat and on all of these forks, they are available. They build nightly snapshot RPMs. So you can just test them, right? Put them in one of your test machines. Run your application tests on them. And in particular, if we broke your application somehow, because it happens, please let us know that now, rather than a month after the release, right? It's so much easier to fix it now, right? We're very happy to have that kind of information. Same if there's something in your application that we suddenly made a lot slower, because sometimes these optimizations don't do the right thing. Right? This is how we came up, I think, with at least reverting of the self-join elimination last time. Right? The number of people reported that like their query stopped working with weird errors because we'd removed joins that they needed. Right? But if nobody tests them, we know that your Postgres has tests, yes, but they are compared to the sum of all your applications. The Postgres tests are very limited. So throw more stuff at it. Get it rolling with those. If not, again, expect current plan is something like May-ish timeframe for a beta version, and then September, October-ish for the full release, and sometime during summer we'll be looking at release candidate versions. That should be all ready to go. So that's all for me for this time. I think I'm basically right out of time, but I will be around if you have any questions. We won't really have time to do them now, I think, but just grab me in the hallway afterwards or between. I'm happy to answer anything around this or any of your other Postgres questions that you have around. Thank you very much.
So we do have a couple of minutes for questions. If anybody
perfect.
has one, I'll bring a microphone over to you. Anybody?
There's one over there.
I can just speak loud.
No, we need it for the audio, please. Is it on?
Yeah, I would say so. The talk is being recorded, so you are now being recorded.
Thank you. 3 quick questions. First of all, UUID 7, will that require installing an extension or it's built in?
UUID version 7, that's built in. There is already today, there is a third-party UUID v7 extension that you can find and install, but the big thing here is, yeah, it will be built in, so all there by default.
The temporal IDs, would that be the de facto way or the best way to build scheduling systems for booking systems and things like that?
I think it's not directly. I think today, if you're looking at scheduling system and booking system today, the time ranging is that. Now, if you need foreign keys that include the range, then yes, this is what you need. If you just need, bookings that have start and end times and not having overlaps and stuff, we already have that in general range types with exclusion constraints. But they don't support foreign keys with overlaps. If you wanted to do that prior to this, you have to write your own trigger with manuals and stuff, and that's all automated.
Okay, great. Last question. Does delete also have the returning clause?
Yes, delete will also have the returning clause. So you can do delete returning and get what you ended up deleting.
Yeah, excellent. That would be great for a queue system instead of, remove.
Yep, absolutely. In many cases, delete everything that happened within this time range, but let me know what I just deleted, please.
Thank you.
That's all useful. Yep. Got another one over there.
One more over here.
Yeah, it's mandatory. There has to be one over there and then one over there and then one over there, so that they get to exercise.
So we can play tennis, yes. My question's on the temporal foreign key thing again.
Yep.
Your examples were with overlaps. Is there any work towards strict inclusion or strict? Because perhaps on the foreign key, overlapping isn't going to be enough. I'm going to want to know that it's strictly contained or that the parent is strictly.
So I don't think there is any work on that right now. I don't think that's, because the work right now is based on what's in the SQL standard, and I don't believe that is in the SQL standard. Maybe someone can correct me if I'm wrong, but I don't believe it is. You can still accomplish the strict containment things today, but again, you have to do it sort of in user space. With the trigger, because Postgres range types will have the ability to do strict containment, but the SQL standard mapping functionality, I believe, does not. And I haven't heard of anyone working on it right now.
Okay. Everybody good? Perfect. Well, once again, thank you, Magnus, for coming out. Certainly appreciate it. Round of applause.
Thank you.
There we go. Turning it on will help. There we go. And if there's somebody named Pablo in the room, you might want to check the security on your display since I almost mirrored to yours. Okay. There we go. Oh dear, there's somebody who actually knows about Postgres in the audience. Now I'm intimidated. Somebody who actually knows something about Postgres in the audience. I'm intimidated now. Okay, before I actually start, while we're waiting for people to arrive, how many people recognize where the phrase language is a virus comes from? That's actually a quote. Okay, just curious. So the joke is totally not landing, but oh well. I'm sorry? I will. It's actually, the original quote is from a William Burroughs spoken word piece where he says language is a virus from outer space. And Laurie Anderson recorded that on one of her albums. So it's fairly nerdy, so. But it is also an indirect reference to the problems that locales and other language things have caused in Postgres. So let me know when we're ready to go.
Postgres still solves them better than any other product, right?
I'm sorry?
Postgres still solves them better than any other.
Well, I would say yes, it does, and we'll go into how. It's a hard problem, which is kind of 1/3 of the talk is how hard it is, the problem is.
All right. Hey, welcome everybody. This is SCaLE 22. Glad you all made it. You are in the Postgres room where we are lucky to have Christoph Pettis with his talk, Language is a Virus.
So hello everybody. My name is Christoph Pettis. I'm the, I'm the CEO and lead consultant for PostgreSQL Experts. Well, we're now a PGX Inc., but we are a boutique Postgres consultancy. We're based up in Northern California in scenic Alameda. And I've been doing, my first version of Postgres was version 7.0, so I've been doing Postgres for a while. And this talk is about why language was a bad idea and we should have just never done it. Well, okay, just kidding about that part, but it would be a very short talk without language. But the gist of it is, so how does Postgres handle multiple language support, and where does it go wrong, and what should you do? So there's a little bit of introductory information, which I think many people in the audience will know, but I want to set levels. So the first thing we're going to talk about are glyphs. So what is a glyph? The official definition is any kind of purposeful mark. So when you X out something on a thing, that's a glyph. But we're more interested in language communication. So those are glyphs, AZ for U with an umlaut. Those are glyphs too, the cartoon swearing on the next line. Glyphs, these are glyphs in other languages, that are non-English. And emojis are glyphs too. So there are two terms that are used for them. My actual degree is in linguistics, and I did this stuff, and I feel that computing kind of got adopted some bad terminology, but here we are. So the glyph is the mark itself. So even though those are all the lower letters A, they are 3 different glyphs because they look different. The underlying functional unit is called a graph, in linguistics is called a grapheme. And those are all the same grapheme. They're all the letter B, even though they're in different fonts. And computing, for some reason, decided to use the word glyph to mean grapheme. So we're going to use the word glyph to mean grapheme, but they are technically different things. But we're all computer people, and we talk about characters all the time. So what's a character, if we're being formal about it? More or less, it's a glyph. There are some exceptions. Unicode has a thing called combining characters, and that somewhat fuzzes up the distinction, the boundary between a character and a glyph. For example, is E with a diacritic there, is that one or two glyphs? And you can actually get into fight, you can pick a fight with a linguist over this stuff. It may be that the E is one glyph and the dots are another glyph, or the whole thing is a single glyph. And, so if you ever want to cause a linguistics conference or break out into a fight, now you know how. And of course, because the best thing about standards is there's so many to pick from, Unicode supports both models, which is a pain, and it's also fortunately beyond the scope of this talk. But it's almost safe to use the terms glyph and character interchangeably. Close enough, we'll do that. So about 30 seconds after we invented computers, we realized that we'd like them to do things other than numbers, and so they needed to represent characters. But they still only did numbers. I don't think anyone's actually built a computer where the fundamental unit of storage is an alphabetic character. Although for a long time, when I first learned about computers, and my first language was assembly language, and somehow I thought the A, B, C, D, E, that the last digits of the hexadecimal alphabet, of the hexadecimal range, those were actually literally stored in the computer as the letter A. So I was disabused of this notion quickly. So we need to map the letters that we all use, the characters we all use for language, the glyphs, to numbers. The official hip and with it term for the number that represents a character is that character's code point. So we'll use that. And if you have a complete set of code points for some reasonable group of glyphs, like all the glyphs that are used in US English, that's called a character encoding. And for a long time, what we meant when we said character encoding is we meant ASCII, which stands for American Standard Code for Information Interchange. It basically was done in 1967, so it's been around a long time. It assigned a 7-bit code to the traditional Latin alphabet and to Arabic numerals and a few commonly used at the time symbols, basically the characters you could find on an ASR 33 teletype, and some control characters. And so A is hex 4.1, and lowercase a is hex 6.1, and asterisk is hex 2a. And it was actually pretty well thought out, especially for computers of the era where 64K was a lot of memory. For example, if you take the uppercase letter and add hex 20 to it, you get the lowercase letter, nice and easy. If you take a digit and subtract 30 from it, you get the actual numeric value for the digit. If you're trying to write something that fits in like 18 bytes, that's really cool. And for a long time, this ASCII was all we had. There was another character encoding, EBCDIC. Quick question, who has ever heard of EBCDIC? Wow, many more than I would have expected. But we don't talk about EBCDIC because EBCDIC was originally invented based on punch card codes, so you know. Now we tend to call this original encoding 7-bit ASCII, which is technically redundant because ASCII only defines 7 bits of data. But we need to distinguish these because the instant we came out with ASCII, it was obsolete. Because it really was designed to handle the kind of letters you would find on a 1967 vintage computer terminal, where lowercase was like a big deal then. And there was no way of encoding characters that are commonly used in any language besides English, and in fact English plenty of times uses like diacritic marks and things like that, and there was no way of representing those. And if you don't use the Latin alphabet, forget it. There was no way of encoding that in ASCII. So immediately, everyone took ASCII and ran off and added to it to be able to encode their own language. Some used the characters larger than 7F, some used multi-byte characters, and it was total chaos. INA documents 259 different encodings, and there are plenty more that just have never been standardized. Which brings us to our attempt to solve the problem, which is Unicode. The idea behind Unicode is, like its name implies, it was a single character encoding for everything. The goal is to assign a glyph to a code point, a number, to every glyph that is used in human communication. That's a very ambitious goal, but I respect it. Pragmatically, Unicode represents, has a 20-bit character code. The standard on Unicode is to write code points with a U plus and the hexadecimal number, so we'll do it that way. For all the characters that appear in 7-bit ASCII, the first 3 bytes of a Unicode character are all 0, if it's a 32-bit, represented 32-bit number. The basic multilingual plane basically is the first 16 bits of Unicode. That's most, not all 100%, but most natural languages have their characters land in the basic multilingual plane, so 16 bits. Obligatory Tolkien reference, Tengwar, is the Tengwar alphabet from Tolkien's writings. It's not actually a formal part of Unicode yet, but they have reserved a code space for it. So whenever they get around to standardizing it, they've got, that it'll be from that range of Unicode points. So we now have the perfect character encoding. Well, yes and no. If we're going to be very precise, Unicode is Unicode a character encoding? And the answer is kind of, well, yes and no. It does do the basic thing a character encoding should do, which is it takes code points and glyphs and maps them to each other. So you have a character, you have a number. That's a glyph, you have a number. But the Unicode spec as such doesn't say how we cram these into a computer. Remember, we have 20 bits, which, pragmatically you have to round up, so we have either 24 or 32-bit characters. So the obvious way is just we declare every character as a 24 bits, is 3 8-bit bytes, and we're done. But we've just increased the size of nearly all text stored in the world by 3 times, and that was deemed undesirable. So the next part of the spec was the Unicode transformation formats. So if you ever wonder what UTF stands for in UTF-8, that's what it stands for. We're encoding and encoding. Isn't it great being in computing where we do things like this? Because there are more than 8 bits in a Unicode code point, Unicode characters in UTF-8 are variable length. So in UTF-8, if it's an ASCII character, 7 bits, it appears with the higher order bit 0, it appears just like it always did. So UTF-8 is a superset of 7-bit ASCII, which is super convenient because you can convert 7-bit ASCII to UTF-8 just by saying that's UTF-8 now. Of course, you have to remember you said that, but it's pretty convenient. So UTF-8 works by, you scan a long character string. If it's less than hex 80, you interpret as 7-bit ASCII. Otherwise, the 32-bit code point is represented as a byte sequence, like, there are a couple of examples there. The problem is, this breaks the string comparison operation in Unix, and a whole lot in the entire universe uses that operation. Because let's say we compare uppercase Z and E with dots, okay? It says that the Z is lower because the byte strings are lower. But that's wrong for every language. I'm sure that there's a language where it's right, but for every natural language I'm aware of, that is wrong. And now things are out of sync because you've compared one character and another, and now it's like comparing the middle of byte sequences. It's just, it's not going to work very well. So we're kind of still struggling with how to make UTF-8 work in a lot of situations, because we had decades, generations of code that assumes that a character is 1 byte. And the code, if you're reading UTF-8, you need to know it's UTF-8 so you can decode it properly. I mean, we've all seen that garbage on a web page, which is what happens when a UTF-8 character gets shoved at a browser that thinks it's interpreting it as ASCII, or some weird variation of ASCII. So how do we know we're sorting these things in the right order? So now we're getting into the database part of it, which brings us to collations. A collation at its heart is just a function. It takes 2 strings and says, this is greater, this is less than, or these are equal to each other. That's what it is. So when people talk about a collation, they're really talking about a piece of code in the computer that compares 2 strings. There are lots and lots and lots of collations out there. It's probably an unbounded set, in fact. Each collation at the computing level is specific to a particular character encoding, because it needs to know what these bytes are that are being thrown at it. But a single encoding can have lots of different collations. Just on my laptop, UTF-8 has 53 different collations for different languages and things like that. Generally, a collation is specific to a particular natural language. But natural languages can have more than one location. A famous one is that German, in lists of names, sorts differently than words in a dictionary. So, which is interesting. Danish has a second collation specifically for Greenland, Greenlandic Danish, sorts differently than continental Danish. And languages also have different, languages are different from each other. You heard this here first. Languages also have different ways of formatting numbers, dates, all sorts of things. So finally, some rationality was brought to the whole system. We created bundles of stuff for languages, and tried to package all these different characteristics together, and we called it a locale. So that's what a locale is it's just a bundle of code and supporting data. It provides a set of utility functions which do a bunch of stuff, like number formatting, character encoding, some utility functions like how you take a character and make it uppercase in a particular encoding. The date, the time, everything. But the part we're interested in is the character encoding and the collation part, because databases sort strings a lot. On pretty much any Linux system or Unix system, what you'll see are called POSIX locales. I think Windows has a different locale system that is confusingly similar to, but not the same as POSIX locales. I think people have seen these kinds of things on their systems. So a typical locale name looks kind of like this. The FR is the language, was French. So the BE is the region, because different regions, the French in different regions has all kinds of different rules. So BE is the region, which means Belgium, and UTF-8 is the encoding. Sometimes you see the UTF-8 being dropped if the only locale that the only character encoding this locale exists for is that particular encoding. So the UTF-8 might be optional. There's also this one big exception locale, which is called either C or POSIX locale. This compares strings byte by byte, just like we always did back in 1967. It's really fast, uses strcomp, but it breaks for any non-7-bit ASCII character in UTF-8 or UTF-16. It can even break for equality. Like, because of that composing character thing, those two characters may not compare because they're encoded in different ways. But you can't see that. So use this with caution, and I will talk about when is an okay time to use C or POSIX locale. So we have all of these locales, zillions of them, and they are provided to the code by binary libraries, which are called locale providers. Pretty much on any Unix-derived system, they're provided by the library libc, the runtime library for the C language, which on most systems that anyone actually comes into contact with means the GNU implementation of libc, which is glibc. This is so common, in fact, that you'll frequently hear POSIX locales just called glibc locales, because that's where it gets them from. There are other locale providers, and there's at least one, and there's one really cool one. Maybe there are other cool ones. The International Components for Unicode is part of the same general environment that produced the Unicode spec, and it also has a locale provider. So it will ship you a bunch. You install it. Most systems don't have it pre-installed, but apt and yum are there for you. And also, as of version 17, Postgres has its own locale provider, and we'll talk about why it has it and what good it is then. So a quick note about ICU. It's a bunch of utility functions for doing Unicode things, and includes a lot of locales. In fact, it has a build your own locale system, which is pretty cool. You can have locales like that string, which means it's US English, but sort numeric strings as if they were a single number. So 1, 2 sorts after 1, because it treats it as a number rather than just a string of characters. And by the way, sort case insensitive, please. So Postgres has supported this since version 10. So it's pretty cool. Also, it includes a secret weapon, which is this collation, UNDXICU, which is a good enough collation for the entire Unicode code space. It's probably wrong for any particular language. Maybe it's probably okay for English, maybe for most of Western European language. The farther away you get from that, the more wrong it will be. But it's not wacky wrong, it's sort of normal person wrong. So it's good enough for non-specialized uses. Okay, finally we're getting to Postgres. So databases need to know about locales because they compare strings all over the place, string comparison, building indexes, output functions, all kinds of stuff. When you create a new database in Postgres, you specify what locale should apply to it. There are some things you can change table by table, but you can't change the character encoding in Postgres once a database is created. It's fixed, it's permanent, nothing you can do about it. It applies to every table in the database, every index. So you have to pick one, which means you should pick UTF-8. See, that was an easy decision. There's really no good reason to use anything else anymore. Unless you know for sure that your database will never accept any natural languages as data, which does happen. You have things that just don't process natural language at all. There are no string, if there are strings, they're like, they're codes, not actual sentences. And string comparison is going to be the bottleneck in the database. If you know for sure that those two are true, you have options other than UTF-8. You probably don't know that. Even if you think you know that, you probably don't actually know that. So just use UTF-8. Because the alternative is you probably are going to be using C encoding. Lots and lots and lots of databases do, especially ones that have been around for a while. And if you use C encoding, it'll accept anything, because there is really no encoding as such. It's just, they just treats them as byte strings. And it will just accept them and do nothing, which means you could, in a single table, you could end up with mixed encodings. This means that they get really hard to display, because when you hand them to a web browser, you need to tell the web browser what encoding you're using, and you don't know. There are libraries that will sniff data to decide what encoding you're using because these problems exist. They're not, their reliability varies because there's a lot of lost data there. So, and if you get into this situation, it's a mess to sort out. So don't use C encoding, use UTF-8. There's also this encoding called SQL ASCII. Occasionally you'll see references to it. Do not use this encoding. If you see a database in it, come up with a strategy to get off of it right away. We're not going to talk about it anymore. Okay, doesn't exist. There, easy. So, okay, well now I've told you what not to use. What do you want to use? It's a slightly more complicated question to say what locale you should use. Most Linux distributions, if you don't do anything, it'll create it as EN-US UTF-8, which is US English UTF-8 encoding. And it's fine, it's boring, it works. But there are better choices. So if you have the ability to sort of plan strategically about encodings, there are some options. But before we do that, we're going to talk about why we care about all this, which was something really bad that happened to PostgreSQL a while back. So just as a sidebar, an index is really a cache. It's basically, it compares a bunch of stuff for you and stores the results in a data structure that's much faster to use than comparing it all over again, okay? And the joke goes, there are only the two hardest problems in computing are naming things, cache and validation, off by one errors. So, and indexes on character strings depend on the collation function, right? I mean, duh, obviously. But what if the collation function changes underneath you without telling you? Now you have a cache invalidation problem. The index is wrong. But if you don't rebuild the index based on the new collation function, you in fact have a corrupted index. This sounds all pretty hypothetical, but it's not. And we found out it's not when glib 2, the most recent example of this is when glib 2.28 was released. And in the release notes, there was this statement. Now, you read this statement, and the thing that does not pop out to me is, oh my God, I have to go reindex my entire database. I don't kind of get that from that, but that was in fact the result of it. Because it changed the underlying collation functions in a lot of glibc locales. And suddenly the queries were returning wrong results. You get duplicate rows in a unique index. It was just a mess. You know, so it's been a while. You know, this was like Ubuntu 18.10. But it kind of left a scar in our collective memory in the Postgres community. And the problem was this cropped up in a lot of different places that were weird. For example, let's say you fired up a new binary replica on a more recent distribution. So you cross that version boundary, and the primary was on one and the secondary was on the other. Now you get different results querying the two systems, which is freaky if you just don't know what's going on. You do an in-place upgrade of the database using PG upgrade. Now bang, suddenly everything's corrupted, but you don't know it. You pick up the data directory and move it to a different system on a newer distribution. A lot of a lot of cloud providers, you do this all the time. You detach the NAS, you move it over to a new system. Or you restore a snapshot, a binary snapshot. All of these could produce it, and none of these kind of make you think, oh, yeah, I should make sure what the collation function is. You know, you don't think about that kind of stuff. So one of the questions was, well, this was a glibc problem. Should we have just used ICU because different locale provider? That would have solved it? Well, it would have solved this problem because the problem was with glibc, not ICU. But glibc collations change too. Less frequently than glibc, but they do change. So how do we solve this horrible problem? The first option is you just monitor and rebuild your indexes. As of version 10 for ICU and version 13 for glibc, if Postgres comes up and it sees that the library version has changed, it will start emitting warnings to the logs every time it says that. So, and it was doing this when glib 2.28, but a lot of people just had warnings turned off or weren't looking at the logs, and you know, things happened. So if you see these warnings, just you rebuild any indexes that are based on character strings. Don't try to like slice this really thin, just do it. Over time, you know, so. Now, as of version 17, we have another option, which is we have a built-in locale provider. It only has two collations, which are C, which works like the C locale, you know, it uses string comp, that kind of thing. It also has C.UTF-8, which just does a binary comparison, but it does it on the code point numbers rather than of Unicode rather than byte by byte. So it's wrong, but it's kind of less wrong. You know, the results are not going to be completely wacky. They may be not great for a particular language, but at least they won't be completely off its space. They both get, you know, Z less than E with an umlaut wrong, but UTF-8 gets it less wrong. The C.UTF-8 gets it less wrong. And these will never, ever change. These collation functions are permanent for the rest, till the heat death of the universe. So you never have to worry about a collation library change. And now you're thinking, I just like want to run a database. You know, what should I do here? This is a lot of really gruesome detail. So here are some typical use cases for people running databases and what you should do. So you want maximum speed and minimal headaches. You're running on 17 or higher, and it's, you know, for something that is beyond 17, if the collation is wacky, I don't really care that much. You know, no one's going to sue us if it's wrong. So just use C.UTF-8 from the locale provider, and all your problems vanish like mist in the morning. It's great. You want everything to run really fast. You're running on a pre-17, and you've raised your hands and swore that you will never, ever allow a non-7-bit ASCII character to enter your database. Then you can use the C-POSIX locale. I am dubious that you are swearing in good faith here, but your database, your problem. This is probably the main use case for the C-POSIX locale. Because again, if we changed how strcomp compared strings, we'd have much bigger problems than Postgres corrupted indexes. Okay, now, but you're good.
Is that on a table level or database level? Or?
You can set collations on an individual table. Yeah, we'll talk about that in just a second. Now you're getting a little more sophisticated linguistically speaking, and you say, okay, I'm willing to give up a little bit of speed, and I want my collations to be like not super wacky across languages, or you're before 17 and you do want to use 7-bit ASCII characters. This is where this magic UNDX ICU locale comes from, shines, because it gives you a pretty much okay sortation order. Basically, within each alphabet or each symbology, the sortation order is going to be basically right. It's just, you know, between them, it's going to be a little weird. And we'll talk about the speed characteristic in a bit. Now, you're building a database and you need it to be spot on correct for a particular language, but that will be the only language in the database. So you don't care about if something's weird about other languages. You just use the libc or ICU locale specific to your language requirements. You probably want to use ICU, but we'll talk about why later. Okay, now you're getting really complicated. You're going to have different languages, and you'd like the collation to be spot on correct for that language, for each language. Oops. Create the data, have the default one be UNDXICU, and then put each language into its own table or column within its table, and set the collation properly for those languages at that level. There isn't a great solution for mixed languages in a single column, which unfortunately is a very common use case because users are typing things in and all that kind of thing. So there is no perfect solution there, but this gets much closer. So you're on 17 or higher, and you just never have to want to worry about any of this. You know, you don't, this is one maintenance task you never want to have to think about. Just use C.UTF-8. Collations are going to be a little weird for non-Latin alphabet, but they're not going to be that weird. But now you're on earlier than 17, but you still don't want this maintenance headache. Then you're stuck using CPOSIX, because that's the only collation from glibc or ICU that's guaranteed never, ever, ever to change. Using SQL ASCII, and more people than they realize are using SQL ASCII because it was the default for a while. So, you're a bad person, you should feel bad. Well, okay, I'm not that judgy, but really you should come up with a plan to move off of it. Numbering issue there. Now, for reasons stated earlier, you need to use libc or ICU, or you really, really want to, but I've just scared the heck out of you that suddenly you're going to upgrade to, you know, a new version of Ubuntu and everything's going to break. So what do? You can, this is totally manageable. You know, it's not as scary as it sounds. You just have to take some maintenance tests. So the first one is upgrade to PostgreSQL 17. That's easy. Be sure you never ever run a binary and a binary replica and a primary on different versions of the OS. And by different versions of the OS, I include different distributions of the same, you know, of it. Don't restore a binary snapshot onto a different version of the OS. And when you change something on you're running, you move to a different OS, you do that kind of thing. If it starts generating these warnings, and the warnings are pretty clear about what's going on, when the system's running, there are two specific maintenance steps. You do an alter collation refresh version that makes sure it's using the latest version of the collation, and then reindex the database. You probably want to put concurrently in there because otherwise you'll lock down the entire database while it's rebuilding. If you have an 8 terabyte database, that'll probably not be a happy thing. A little note on using ICU. There is an extra step you have to take because again, ICU has these like Build-A-Bear locations. Collations. You have to give them a name Postgres, a name for Postgres, which is what the create collation statement does. So it creates a new database object that, with the appropriate, for out of an ICU collation. You can also specify them directly when you do the create database as a version 15 in Postgres. There's one little catch that can be very confusing. If you do this, if you create something with a specific locale, you have to specify template 0 as the origin of the database. So you see that last line, template equals template 0. For people who are not familiar, there are 2 template bases in any Postgres install. Template 0, template 1 is the one that is by default used. And it's kind of a fully functional, useful database. You know, it has everything specified. Template 0 is the basics. You can't run template 0. But in particular, it doesn't have an encoding and a locale specified. So you can specify a new one. Template 1 does have a locale specified, an encoding specified. You can't change those. So anyway. When it gives you the error the first time because you forget, like I always do, that's what's going on. Okay, so I've made kind of vague references to speed through this whole thing, like this is faster than this and this is, so but like some numbers would be great. Okay, So here's the world's cheapest and cheerfulest test that I did on my laptop. But I think these are pretty accurate as a proportional thing. So the built-in C.UTF-8 came in at 486 milliseconds to sort 1 million arbitrary string rows. libc running POSIX was basically the same speed, a little bit faster, but not enormously faster. I would say that's within the margin of error. The UNDX ICU locale collation that I like so much is definitely slower, but it's also definitely better for an individual language. I use the Austrian-German ICU locale and libc locale. And the ICU German locale wasn't particularly slower, so there's no real cost in doing that, so that's good. And libc's was horrible. And I played around with other locales there. libc in general for a specific language was always slower than its ICU counterpart, so just use ICU if you're going in that direction. Okay, so now that we know that, what do we know, as a professor of mine used to say? So the locale stuff is actually kind of hard. Your brain can hurt for a while. But the good news is, as a general DBA or developer, you don't have to think that much about it. You just make make a good decision to start and then forget about it. It is a good idea when you're starting a new database, starting a new, which of course you don't have that flexibility that often. I appreciate that. Spend a little time thinking about what locale you want to use, because it's a decision you're going to live with for a long time. Specifically, don't just take what the system throws at you, because you're going to end up with, enus.utf8. Check out ICU. It's underappreciated because it's not like kind of the default for anything, but it's very powerful, it's really fast, and it has less version stability issues than glibc. And if you think you'll never have 7-bit ASCII characters in your database, you're wrong. You will. It'll happen. So think about how you're going to handle those. And that's everything.
Okay, so we do have time for questions. Any questions in the audience? Okay, give me just a sec. We do want you on the mic.
Obligatory promotional slide. If you need Postgres stuff done, we're here for you.
Can't remember exactly which example it was, but the multiple languages, you want spot-on collation, so you separate them into multiple tables. Can those multiple tables be partitions of a master table that's...
I'm going to say yes,
Okay.
because I believe I don't think there's any reason you can't have different collations in different partitions, which is a pretty exciting idea, actually. I'm going to have to experiment with that. I like that idea. You could use the language as the partition key, and then the constraint exclusion takes care of going to the right table for you. It's a pretty neat idea. I'll play with that. Thank you.
Other questions?
Thank you. Two quick questions. The first one, is there an easy way to identify emojis in text?
I'm sorry, identify.
Emojis, emoji characters. Many
well,
times we want to exclude them, and it's difficult.
It would not be. It would be actually. You could at the SQL level write a trigger function that did so, because you just walk through the string, converting it to a code point, and then the emoji has a code point range like everything else does, and kick it out. From a systems level point of view, I'd probably put that in the app, in the app rather than the database. But if you wanted to write a trigger that said no, sorry, no emoji here, totally possible. There'd be a performance hit, because it does have to take the string apart. Somebody's dumped 85K of text on you, you have to walk it character by character. Not so great, but it's totally doable.
Okay, and the second one, are there any tips for or things to consider differently when you use right to left languages like Hebrew or Arabic?
At the database level, no. They encode just fine. This is one of the places where the glyph versus grapheme distinction becomes really important, especially things like Arabic, which has really significant and complicated character transformations. Like, for people who are not familiar, Arabic, there's a whole different way of writing characters if they start a word or end a word, because of the complicated, the lovely but rather complicated Arabic script. At the database level, they're just code points, so they're fine. The rendering engine, of course, has a lot of work ahead of it to get it right, though. But they're encoded. Since the computer doesn't really know left to right, it knows more significant to less significant. They're always encoded. The more significant comes earlier in the text than the less significant direction.
Okay. Question here.
Hey, I wanted to ask about SQL ASCII. Now, SQL ASCII seems to work for most people, but of course, when they try to extract the characters, because it will happily accept anything, when they try to extract it to some other encoding, it fails. Most distributions and the packages that we have on PGDG default to using your system's encoding instead of SQL ASCII. So who would complain if we change the default to UTF-8 from?
Well, the current default on every Postgres package I'm aware of is to use the system locale, which almost always means enus.utf8 on most distributions. And the good part is then at least you're not going to, it's a safe kind, it's very safe because it's using UTF-8. You're not going to get weird, multiple encodings in a sync table and that kind of thing. I believe if you build from source, I'm going to say that I think this changed, and I'm not 100% sure. It used to be if you build from source that POSIX was the default locale. And earlier than that, it was SQL ASCII. Now I believe building from source, it still uses the system locale, but I don't swear to that. I have to check. But yeah, it's definitely the default on any rational system should be something less undangerous and a UTF-8 encoding for sure. That should absolutely be unless you're running on if you're running on an IBM Z series and need EBCDIC, then peace go with you. But you're probably running DB2, not Postgres. So.
Okay. Any other questions? No? All right. Christoph, thank you very much. Certainly appreciate you being here.
Thank you very much for coming. Oh, I see.
If for any reason there should be some spares over there, but you look like you're pretty full, so.
Hey, everybody. Looks like our speaker has just arrived, so we may have a couple-minute delay. Just wanted to give you a heads up.
If you need a couple minutes, take a seat.
Okay. All right, everybody, welcome back. We are Postgres at SCaLE 22. Our next speaker is Peter Farkas. He is co-founder and CEO of FerretDB, Inc., and he will be talking on bringing Mondo workloads back to open source using FerretDB. Peter?
Makes sense? Better? Cool. Well, thanks for bearing with me. I just got my rental car to break down on the highway. So it's been a great morning so far, but only up from here. So, yes, thank you for the introduction. My name is Peter Farkas, and I'm the co-founder and CEO of FerretDB. Who's heard of FerretDB before? Okay, quite a lot of people. Oh, look at that, some familiar faces as well. Well, thanks for coming. So, okay, for those of you who haven't heard about it, don't worry, this is not a sales pitch. I'm not selling anything, another familiar face there. What I'm going to talk about is a little bit of database history and a little bit of, historical context to what is happening right now on the database market. Now, this is of course not a concrete historical overview. This is just a quick recap on the history of SQL and how it relates to what is happening nowadays with MongoDB. So I'm assuming that most of you are Postgres users, right? Hands up if you are. Yep, most of you. Any MongoDB users? Okay. Well, so we found that there is a significant overlap between those who have to use MongoDB and those who use Postgres, so that's part of the story here. So the agenda for today, why do we care? Why do we move MongoDB to Postgres? A little bit of information on MongoDB's licensing, the thing I talked about, history of SQL as an open standard, whether we should make MongoDB an open standard, the architecture of FerretDB, just for those who've been wondering how does that work, and then a conclusion. So let's not talk about FerretDB or Postgres or anything else. Let's talk about the users. So this is the Stack Exchange Developers Survey of 2024. And if you take a look at this nice graph here, developers were asked, which database environments have you done extensive development work in over the past year? And which do you want to work with over the next year? And it had 76K responses. And of course, to nobody's surprise, Postgres finally took over MySQL as one of the most popular databases out there. And as we can see, it is something which developers desire. Maybe they don't use it today, but they want to become users in the next year or so. The second one is still MySQL, and then there's SQLite, MongoDB, and Microsoft SQL Server. There is an outlier on this graph, and I wanted to ask you if you have ideas on which database is the outlier. Well, I mean, of course, it's MongoDB, so this was not a big mystery. Yes, it's MongoDB, but why? So the reason why MongoDB is an outlier is because, first of all, it's the only document database out there. So if you think about it, for relational database users, we have Postgres, we have MySQL, we have SQLite, all open source. Some of them are a bit closer to Oracle than we would like, but still, these are open source solutions. And there is, of course, Microsoft SQL Server. You would say that's an outlier as well, but only because it's not open source. But the real outlier here, or the reason why this is considered an outlier, at least by me, is because MongoDB is the only document database solution. It's the most popular document database software, and it's also proprietary. So when you compare the opportunities of relational database users, there are plenty, and there are really mature solutions out there. But for document database workloads, there is MongoDB, and that is not open source. So hands up if you thought MongoDB is open source. Yeah, so there are still some of you, and I'm here to deliver the sad news. So MongoDB is no longer open source. They moved to the SSPL license, this server-side public license, which is created by MongoDB Inc. It was used by other companies as well, like Elastic, and they moved back to open source. But SSPL was not an OSI-approved open source license. And the reason they did not approve the SSPL license is because it discriminates against users and use cases. So if you run MongoDB as a service, then you are required to either publish your own source code with an SSPL license or pay a license fee to MongoDB Inc. So they thought that this is going to be a great open source license. The OSI disagreed, and I think most of us disagreed. They still think that it is open source, as we've seen in a cease and desist letter they sent to us. So you can get more information on the SSPL license on ssplisbad.com. I still don't know who created that page. It was definitely not someone I know, but it's a pretty good explanation on why SSPL is bad for you. Okay, so Postgres users here, I know. So why don't you just use JSON? Obviously, Postgres supports document database workloads to a degree, and it works well. And if you have to supplement your relational workload with some kind of document JSON workload, then you can use JSON support, and probably you will do just fine. The problem here is that MongoDB is really not about being a document database per se. MongoDB is an integral part of several frameworks, such as JavaScript frameworks, where the developer really shouldn't know much about the database itself or the underlying structure or the database. They can just implement the whole thing on the application level. So you start your JavaScript framework, you write code, and basically your database structure, your database strategy will be decided on the application level and not on the database level. So it's about the developer experience, and it's very hard for DBAs to understand. It was hard for me to understand as well, but it's true. Developers do prefer knowing nothing about the database. That's the cold hard truth out there, which we need to understand to cater to developers. And MongoDB did a great job with doing that. So I think it's hopefully a bit more clear on why we care about MongoDB users and why we want to move them to Postgres. As a recap, because they got the rug pulled from under them with the SSPL license, and I will talk more about it later. So let's see the short story of SQL, and I promise that this is not going to be a highly accurate representation on what happened with the SQL standard. We only have a couple of minutes to discuss this, but I really wanted to put today's MongoDB situation with how SQL looked like historically and how it evolved into the open standard as it is today. So the short history of SQL, we had Edgar or Ted Codd, a researcher at IBM's Palo Alto lab, and he came up with the relational model. He was the one who basically gave us the first paper on the relational model, which enabled databases to scale beyond the three structured databases they worked with at the time on very early computers. So Edgar Codd published a paper on the relational database theory, but he was also a mathematician. You tend to have to be a mathematician back then in order to do anything with computers. Nowadays, that's less of a problem. But the basic situation with the relational model was that the query language, which Mr. Codd imagined, was only something software developers or hardcore mathematicians understood. So you pretty much had to write a separate program to query anything out of the relational database. So the relational model itself provided a lot of improvement and a lot of great things, but it was hardly usable for developers. Let's think about MongoDB for a second and then continue. So how SQL came to be as a query language is that there were two individuals, Don Chamberlain and Ray Boyce, who worked alongside at IBM with Ted Codd, and they saw the problem of having something great as a technology, but at the same time being very much not accessible to developers or end users out there. So in the early 70s, they published a paper where they outlined this English language-like query language to query the relational database, what IBM experimented with. And this was a great success. So together, SQL and relational databases really brought this awesome era where smaller companies with no dedicated developers or even larger ones with no appetite to employ database theorists could actually use their software. So IBM came out with IBM DB2. There's an interesting thing here. So you had to buy, or you couldn't even buy it. You had to lease these washing machine-sized computers in order to use the relational database and SQL. So you had to lease somebody else's computer, and only then you could use the database software you really wanted to use, what you could use. Does this remind anybody, something we have, nowadays? It's interesting. I mean, this is the 70s, right? This is not today, but is it really history? So if you like SQL, you pretty much had to use IBM. And then, of course, users and developers decided that they really want to move forward with SQL. They really want to move forward with the relational model. And they came up with alternatives to IBM's DB2. So they implemented a relational database. They implemented the SQL query language, or at least something like the SQL language, and came out with different alternatives out there, like Informix, Sybase, or there was this very unknown-sounding company called Relational Software Systems, Inc., which later became Oracle. Now, this is a crazy, interesting story. So Oracle was actually one of the few companies who were seen as the savior of IBM users. They saved IBM users from the terrible vendor lock-in situation they were in. Oracle is so cool, right? Like, they are so nice. But back then, this was really something that users felt about Oracle, that you no longer have to deal with IBM, you no longer have to deal with their sales teams every year to renew their lease on your computer. Actually, Oracle made it possible for SQL and relational databases to run on ordinary computers, which anybody could buy, even smaller companies. IBM initially did not really cater to those users. So obviously, just to go back a little bit here, there is a problem with what happened here. And the problem is that many of these products were not implementations of a white paper. So they kind of implemented what they thought SQL should look like, but actually it behaved pretty differently across all of these different alternatives. So migration between Sybase and Informix, not from a technical perspective, but even from the perspective of internal know-how, was pretty difficult. But nevertheless, they provided an alternative to users. And then in 1986, 1987, SQL became an open standard, and how that happened is that all of these different vendors came together and recognizing the importance of having a standard, recognizing the importance to enable users to have options, because that's actually a good business idea, they created the SQL standard. And this is where I usually have some questions, like whether I think the SQL standard is something all of the relational products adhere to nowadays. Of course not. Of course there are differences. Of course they behave differently, but it's still a night and day difference compared to something which is not standardized. So, so all vendors who implemented the SQL standard were still proprietary, and they still meant a degree of vendor lock-in. And that's where we got to the point where open source projects and users of open source projects embraced the SQL standard and made SQL available to anyone. So that's when SQL really became powerful, where even a smaller company or students or someone who did not feel like licensing software or leasing machines could actually interact with a relational database and with SQL. And of course, there are hundreds of derivatives since then implementing kind of the same behavior. So this is a nice thing to know. I think history is definitely an important aspect when you make decisions on what to use, what to do, how to vote, and stuff like that. So we would think that this is something which was in the 70s, 80s, 90s, you know, times unfortunately long gone. But actually, something similar is happening to document database users out there. So let's look at MongoDB and figure out why is this idiot talking on a Postgres track about MongoDB. I hope it will make sense. So MongoDB had a pretty similar history as the SQL standard itself, or SQL itself. Even though it started as open source, they had pretty similar things to offer to developers. First of all, MongoDB wanted to make it even easier for users to use a database. SQL is so complicated. The relational databases are so complicated. If you want to make them scale, you have to make decisions like the schema or replication or what have you. With MongoDB, you don't have to care about any of those things. You don't need to be a DBA to run a database. That was the promise. And so they achieved market dominance in certain segments of the developer community. As I mentioned, the JavaScript community is very much into MongoDB. And after they pretty much used open source as a marketing strategy, and this is a quote from their CEO, they went proprietary in 2018 after capturing more than 20% of the document database market. So all in all, how they started, because they had open source in the 70s, open source was not really a thing, but when MongoDB started out, they had open source. They realized that in order to appeal to users, you have to start an open source project, build a business around it, and then, unfortunately, their strategy was to change the license. Not only that, but they also wanted to redefine the meaning of open source. So evil companies like AWS or Microsoft Azure or some others are trying to take our software, and this is the only reason why we want to make sure that, we have this different license where there are certain limitations. Yes, in some sense, MongoDB was right to look for alternatives, to look for ways how to keep the hyperscalers from leveraging their software for free. They tended to do that back then. I'm not sure to what extent they do it now. But the SSPL license was not just something AWS needs to care about. It's also something users need to care about, because if you think about it, if you limit the amount of available providers, you also limit the amount of competition. You have only a couple service providers to provide a service for you. They have to pay license fees to MongoDB, meaning that there is not going to be competition between the providers, or much less so compared to the relational world. So this is a familiar slide as we talked about SQL alternatives, but it's kind of the same situation. It's just the same situation in a more modern age. So let's look at this. MongoDB came to the conclusion that they changed the license in 2018. It was no longer GPL, it was something else. And then those companies who provided MongoDB as a service or had anything to do with MongoDB started to look for alternatives. And the really large ones were able to build their own implementations, very similarly to how it happened with SQL and relational. So Oracle, I'm not sure if they are seeing the Lord and Savior of MongoDB users out there at this point. I think it's hard for them to have that as an image. But they definitely created their own MongoDB compatible alternative based on Oracle. And then Microsoft Azure Cosmos DB for MongoDB, another MongoDB alternative built on Postgres. So they started turning Postgres into MongoDB after the license was changed. AWS Document DB, another capable alternative to MongoDB, and the less known, at least this part of the world, less known Gauss DB, which is, I think it's Huawei. In any case, these alternatives were implemented for the same reason as back then the alternatives to SQL supporting database alternatives were created, to provide options for users and to make sure that MongoDB is not able to kill competition totally. But the problem is the same. So if you take a look at all of these alternatives, all of them live on a specific cloud service. Oracle Cloud, Azure, AWS, Huawei's own cloud. It's all proprietary. They work in a similar way. Their feature set might be similar, but actually it's impossible to migrate between them because it is not following an open standard. So they have a vastly different feature set. Therefore, if you're a MongoDB user and you're happy about finding a MongoDB alternative out there, that doesn't mean that you really have a full-fledged alternative which would support all of the features out there you are used to as a developer. You can't just start coding blindly or to migrate your application because it's just not always possible. And the second problem with MongoDB alternatives is that for a MongoDB alternative, MongoDB sets the pace. So you can't really provide an alternative which is 100% compatible because it's a moving target. Who knows what feature is going to be deprecated in MongoDB? Who knows what feature they are going to come up with just to make sure that you are not going to be able to become compatible with that. There is a very interesting website, I hope I can show you, is Cosmos DB really MongoDB? Hopefully this is the domain. Yeah, so this is MongoDB's website. They actually created is Cosmos DB really MongoDB and is DocumentDB really MongoDB.com out there, just to showcase that there are failing tests and missing functionality in these alternatives. But actually we registered is FerretDB really MongoDB early on, so you know, at least there's that. So who cares about 100% compatibility? They totally missed the point, and I think this is a marketing gimmick, because if you think about it, most users would not use all of the features. It's true for Postgres, it's true for MongoDB, it's true for anything else you're using, whether that's an OS or something else. So what we concluded with several vendors and users out there is that we are in need of an open standard which actually describes what document databases should be capable of, the feature set they should be having to be competitive with other solutions out there, and to make users able to migrate between different products, different derivatives of this open standard. That would be undeniably very good for users. And then what is FerretDB? That's one of the last parts of my presentation. So what did we do to make sure that there is some progress on making it possible for users to migrate from MongoDB to Postgres, pretty much? So we created FerretDB, which is a MongoDB compatibility layer. It's written in Go. It uses Postgres as the backend. It's usable anywhere you want because it's Apache 2.0 license. And initially, what we did is we created a very lightweight proxy which translated SQL queries into, translated the MongoDB via protocol into SQL queries. But at the end of the day, even if we leverage the JSON compatibility, that's going to be much slower than vanilla MongoDB. So of course, this was not a sustainable solution. We came out with our tech demo in 2021, and we wanted to show that it is, or it should be, at least possible to do that. So MongoDB compatibility in itself, as I explained, should not mean that it's 100% compatible or that it has the full feature set of MongoDB. What we want to do is to arrive on a base feature set which most MongoDB users can use, or most developers, they don't even have to be MongoDB users, can develop against. This means that, for example, with FerretDB or most of the alternatives out there, you can actually start MongoDB's own tools, like MongoDB Compass, or tools you use for migration between two MongoDB databases, and they happily run with the alternatives out there, even though Postgres is the database in the backend. So all of the frameworks, all of the applications are possible to use. Let's look at the architecture, or what we did to address this problem. So we thought that the main reason for MongoDB's adoption is user experience, that you just take the MongoDB driver, you compile it with your application, and then you don't have to care much about the database to a certain degree. The MongoDB drivers, as you can see on the chart here, are Apache 2.0 because there is a need for you to be able to distribute it with your software. So it can't be an SSPL license or a non-permissive license. So MongoDB drivers by MongoDB are still Apache 2.0. However, the engine itself, the MongoDB API and the WireTiger database engine they're using are covered under the SSPL. So our concept is to keep the MongoDB drivers. They are fine as they are under Apache 2.0. And if you look at the bottom chart, we recreate the experience which the MongoDB drivers provide and get FerretDB to interface with the drivers, implementing the MongoDB Wire protocol, which interfaces with Postgres. A very new change in how FerretDB operates is that we actually work together with Microsoft, who were kind enough to open source the engine of their own MongoDB alternative, Cosmos DB for MongoDB. So now FerretDB uses the same engine to implement, for example, Bison, MongoDB's Bison support in Postgres, enabling us to use the same data types as what MongoDB does under the hood, not having to work around these issues. So there is this interesting progress with getting MongoDB back to open source, moving towards a common standard by implementing alternatives based on the same engine. That means that the feature set is going to be very similar, the behavior is going to be very similar, and ultimately this is what we want to do. This is a slide which I use when I speak on events which are not very much focused on Postgres. So I think it's obvious for us why Postgres is the choice here as a backend. It's fully open source. There's a large community. We were really surprised how interested the community was to address this problem for MongoDB users, to enable Postgres to do more for beyond the usual user base. And of course, as even on today's session, there are quite a lot of users who use MongoDB and Postgres as their database solutions. The crazy thing about FerretDB is that since we rely on Postgres and the DocumentDB extension, we can turn any Postgres as a service provider into a MongoDB as a service provider. What this means for users is that compared to MongoDB solution, which only runs in a handful, like literally a handful of providers, now it is possible with FerretDB 2.0, which just got released yesterday as GA, to turn any Postgres solution, whether it's on-prem or a cloud-based solution, into a MongoDB-compatible database as a service, which is going to bring the price of running MongoDB applications down. So just some history here with FerretDB 1.x. So as I mentioned, we just created FerretDB in a matter of weeks in 2021, and we published it on GitHub, and we got 6.5K stars in 3 days, which told us something about the interest from the user side to move from MongoDB. But it was really not a good solution. It was a proof of concept where we stored documents in index.jsonb columns. We fetched pretty much all of the requested documents with SQL from Postgres, and then we did the filtering on the FerretDB side, which was extremely slow, sometimes 100 times or more slow than MongoDB. So there were quite a lot of differences we had to make sure we find a workaround for. So for example, field order in BSON documents is significant, while this is absolutely not a thing in JSONB. So we had to work around these limitations, which further increase the overhead on the performance. As you know, BSON has more data types than JSON, so we do have data types in MongoDB which was not possible to be stored with the JSON functionality of Postgres. This was a further workaround we had to make sure we cover. So unfortunately, this further decreased performance. I'm not going to go into all of the details here, but probably the most interesting is how MongoDB behaves to anything else you've seen before. For example, these guys. So actually, applications do rely on this behavior. So if you are dead set on creating a MongoDB alternative out there, you can just say, hey, we can do this much better, or hey, this is just not right, or hey, I'm uncomfortable right here looking at the code I'm writing. But MongoDB applications do depend on this behavior, and therefore we have to make sure to implement support for all of these different behaviors. We even had to replicate bugs on the FerretDB side just to make sure that we behave the same way as MongoDB would. Of course, we achieved this extensive knowledge on how MongoDB behaves by running our own compatibility tests and the MongoDB API tester tests. And of course, lots of user feedback, lots and lots of user feedback. So after 3 years, about a year ago, we started working together with Microsoft, where we thought that we need to do better for users. They have a MongoDB alternative. We have a MongoDB alternative, an open source one as well. And the first step towards achieving some degree of standardization is to combine our products into one, and this became FerretDB 2.0. So we use a custom extension called DocumentDB by Microsoft. DocumentDB was released together with FerretDB 2.0 with an MIT license. This is not AWS DocumentDB. They have a crazy thing going on with the names out there. So first Microsoft was DocumentDB, then AWS became DocumentDB. Now Microsoft looks like decided to go back to DocumentDB. But this extension introduces lots of functionality like the missing data types to enable us to not use all of these workarounds, which enabled FerretDB 2.x to perform as well as MongoDB in certain use cases. In some other use cases, it's still slower, but this is something we are really comfortable with at this point. As I said, not all workloads are possible to migrate, but we're getting there. 2.0 GA is available since yesterday. If there are any maintainers of Linux distros out there, pretty much all of you dropped MongoDB when they moved to SSPL. Now we have an alternative for you. So what should we do? We have a public roadmap where you can, of course, after testing your own workload, you can suggest fixes. You can suggest new features, which may be available for you if you're a MongoDB user, but not yet supported with FerretDB. And we are regularly adding these suggestions to our roadmap. There is no other way to create meaningful compatibility than testing and evolving on our feature set. So, conclusion for today. As Postgres users and as Postgres and MongoDB users, I hope that my presentation enabled you to understand a bit more on why am I such an idiot to talk on a Postgres conference about MongoDB. We think that MongoDB is going to become the similar commodity as SQL. We believe that there are users out there who we can help with Postgres, users who are not Postgres users as we speak. I think that it is the Postgres community's interest as well to look at more workloads and enable more users to run Postgres. We do think that we lead the way with FerretDB to open up the document database market. We do believe that this is a great start in standardizing document databases. We are relying heavily on the Postgres community to make this happen. So we do have lots of contributors and lots of advisors, regular testers of FerretDB, or Microsoft even, who contributed this extension to the Postgres community. And we are always looking for more, of course. You can try FerretDB if you visit docs.ferretdb.io. We have a super simple Docker image you can run. It runs Postgres for you and FerretDB and with the extension installed, so you can use that to evaluate your MongoDB workloads against FerretDB. On our GitHub, everything is pretty much out in the open. So if you would like to make suggestions, if you would like to tell us that this is the worst idea you've ever heard and we should all rot in hell, you can do that as well. That's also feedback, and we got some feedback like that. And of course, please follow us on the Fediverse. There's our Tech Hub social link, and at ferretdb.com. With that, thank you, and let me know if there are any questions.
Yep. Thank you, thank you. All right, got any questions?
Just not in Hungarian, Robert.
What was it?
Just not in Hungarian.
Yeah, no. Can anyone hear me? Good. Okay. So we have recently had developers request DocumentDB with AWS for various reasons, but now we have a problem where we have people who don't know how to query MongoDB itself or DocumentDB, and then you have developers developing against that. So I guess my question for you is, does FerretDB let us, say if I'm a non-MongoDB user, somebody that's wanting to normally query the backend, is there a way to directly query the backend to go around FerretDB or?
Yeah, so the question was whether it is possible to query the same database with MongoDB and with SQL, or with the MongoDB driver and with SQL. Yes, so it is entirely possible. What FerretDB allows you to do is you have a vanilla Postgres instance with the DocumentDB extension running, and you can interface with it the same way as you would. Yes. Yes, and then you can query the same database through your MongoDB application, through the MongoDB driver of your choice. That's something which lots of users are looking forward to.
Okay. Additional.
But I'll let somebody else go if they have.
Other questions?
Okay. So what happens if MongoDB goes back to being open source? What happens to FerretDB?
So what happens if Oracle becomes open source? So I don't think that, maybe there is a certain degree of understanding that there is a database which is good for everything. There is a database which, in all cases, is the most optimal situation. And sometimes the Postgres community, also tends to give those vibes. And then the MySQL community, like, why would you use Postgres? And it's a big back and forth. Or NoSQL is going to kill SQL. I'm still waiting. It's not going to happen. What happens is that there are different flavors of open standards in the database world, and it's a good thing that there are certain specialized databases, there are certain databases you would never use, but there is some workload out there which is going to require vector databases, for example. So new kids around the block, slowly but steadily, they are going to be available in established order database projects, just like how Postgres developed JSON functionality. So, so I think that it's great to have innovation. If MongoDB goes back to open source, I do think that they have lots of things going for them. We are not here to kill MongoDB, even though they are sending us love letters with their legal team very, very frequently. We are not out there to make MongoDB bankrupt. What we want to do is to open up the document database market the same way as how SQL did. It's not just IBM today or IBM and Oracle. It's hundreds of different flavors, and I don't think that we should argue that these alternatives exist. Rather the opposite. We want to embrace these alternatives. We have this initiative called opendocdb.org. It's about the open standard I talked about. So we have a manifesto there, which is a lot like what I've been talking about today about the open standard. We do have some great supporters already for this open standard. We think that both, all of the hyperscalers would be interested in such standard. And that is also to make sure that we open up the market and create more alternatives rather than being angry at MongoDB or or be concerned about how open source they are. In fact, we did invite MongoDB to support this initiative. There was this VP screaming at me on a Zoom call. It was tough. It was definitely not pleasant, but we do hope that with time they will understand that it's good for them as well. And actually answering your question, I do hope that they will go back to open source, just like Elastic did.
Okay, additional questions? Yep.
Thank you. We're using a lot of MongoDB.
I'm sorry, I have a hard time hearing.
I'm sorry. So we're using a lot of MongoDB, like, you know, multiple different versions, and it's a sort of situation like you were saying where the developers don't really want to know too much about the database. So that creates a weird situation, because how do you find someone to be the DBA when it's the kind of thing where, you know, there's no DBA for MongoDB? So I need some advice, if anybody can provide it, on like how to find someone to be a MongoDB DBA.
But, okay, so as I understand, your concern is being a DBA is something normal in the relational world, and the document database world, it's not really a thing. So first of all, if we bring Postgres workloads on MongoDB, sorry, no, that's like totally wrong. If we bring MongoDB workloads to Postgres, you mostly need a Postgres DBA in that situation, because what you will need to care about is how will your backups work, how will your security look like, how will your Postgres instances scale if the demand is higher, and so on and so on. Having MongoDB as one of the use cases for your database infrastructure will look like similarly as to how your other workloads would look like from the DBA standpoint. At least that would be my understanding. But even if this poses challenges, let's look at AI nowadays. I realized that some of my younger friends, family members, and even the older ones started to look for things on the internet through AI. So I would wager that Google search or searching on the internet is also on the way out. Like there is an abstraction layer on top of an abstraction layer on top of an abstraction layer. MongoDB is one of these abstraction layers for developers to make sure they don't have to think about the database. That doesn't mean that the AI backend will not need people to run it, right? It's actually a huge undertaking to make that reliable. On the other hand, you know, similar thing with Postgres taking on more workloads. It's going to be some additional thing a DBA will need to think about whether that MongoDB workload on Postgres, and let me correct myself, at that point it would be a document database workload. It would be an unstructured data workload. Will not be called a MongoDB workload. Similarly, you know, the vector databases of today will be just vector functionality in some mainstream database. So what I mean by that is if you take a MongoDB or document database workload, 10 years from now, it will be a routine thing for a DBA to take care of, rather than having to learn something totally different, like how to administrate a MongoDB database backend. I hope no one will have to learn that, because the open standard will enable us to ignore exactly that. I hope I answered your question.
Okay. Anybody else before we go ahead and let Peter go? No? All right, if you would please give me one more round of applause for Peter for coming up. Thank you for a great talk. Appreciate it.
Thanks. Hi.
I've only used Mongo and I was forced to.
Two, two, hey, two. Two, two, hey, two, hey, two. Two, two, hey, two. Two, two, hey, two. Two, two, hey, two. Hey, two. One, two.
All right, welcome back, everybody. So we are Postgres at SCaLE 22. Hope you all had a good break. We're now going to welcome Devram Gunduz, who's going to be talking about extending PostgreSQL. So if you want to give him a warm round of applause here, we'd appreciate it. I'll turn it over. Thank you.
Thank you. Welcome to SCaLE. Please raise your hands if it's your first SCaLE event. First, great. 2, 3, yay, more than 5. Great. Thanks for coming back. Thanks for coming back. In this talk, I'm going to talk about Postgres extensions. My name is Devrim Gündüz. I work for EDB. I have several titles that I don't know, but last time I checked, I was Postgres expert. I don't know what expert means, but anyway. Yeah. So this is my LinkedIn and Instagram, and I'm on Blue Sky. I have some appearance on formerly Twitter, then called X. I'm no longer posting them, so for good reasons. So let you know. So don't expect a happy story in this presentation. So I'm not here, thank you. I'm not here to talk about saying that everything is great, because everything is not, okay? And this talk will be mainly focused on those stuff. If you have any questions, please raise your hands. At the end of the talk, I will have a few minutes for extra couple of questions as well. So I'm one of the Postgres major contributors. I'm responsible for the Postgres official community RPM. So if you are using Postgres on Red Hat, Fedora, SLES, Alma Linux, Rocky Linux, I'm the one who does the RPMs. I also contribute to Fedora and Rocky Linux. I've been using Postgres in 1998. I'm the guy with the Postgres tattoo. So there is a real tattoo, it's not a painting over there. Yeah, I hope they don't change the logo every year. Yeah, and I live in London, and then I live in Istanbul, I live in Chicago, and I live in the airport lounges. I took more showers in the airport lounges than I took the showers in my home, so we'll see. And sometimes I DJ, you know. Yeah, I do. So anyway, so I'm going to start with the history of the extensions first, and then continue with the introduction, and then the issues, which is the main part of the stuff, and then the favorite extensions and all the things about RPM. So the question is, are you using Postgres extensions? Are you using Postgres? Okay, good. Who's using Postgres extensions? Okay, the talk is, the target of the talk is to increase the usability of, not users of the, not usability, but users of the extension. So yeah, everyone says they are using extension. So, you know, I have a trademarked, not trademark, but you get copyrighted stuff. So everyone is a PG statements fan, even if they're not. Even us Oracle guys, they're a big fan of PG statements, right? They do. So what did we have in the past? I mean, in the past, we had something called contrib modules. We still have them, but the names is different. So contrib modules are the things, the extensions or the like software, let's say, which is in the Postgres tarball, but in their own directory, which is a contrib module. So they're included in the tarball. They could do new data types, new operators, new functions, new indexes. So there are multiple things that can be done or added, I should say, with the Postgres extensions or contrib modules. And they are not in core, but they are not out of the core. So for example, if you are using the Postgres RPMs, all of these contrib modules are in a separate package because of historical reasons. But if you are using the APT, I mean Debian Ubuntu packages, they are included in the main package. So there's a bit of discussion or a bit history over there. So they have their own individual installation scripts and uninstallation scripts. That was what we had in the past when we didn't have the extension stuff. It was the same thing, extension underscore name.SQL, SQL, not SQL, sorry. And then uninstall extension name.SQL. And of course, there were some versioning issues, dependency issues which cannot be resolved immediately
I'm going to talk about those dependencies later in my talk. And it's hard to get a new one into core. I mean, I may be wrong though, but the last one that went from the contrib modules into the core was tsearch 2. The full text search was the last one, and I think it was about 15 years ago. So that's how it's done. And then there were some external contrib modules, which is not maintained inside the Postgres tarball or Postgres, say, core team, core developers. Sorry. And then external developments, they have the similar installation stuff, same problems, and then we have Postgres extension build system called PGXS. That's still being used widely, and this is the main of how we build extensions. And then Postgres meets extensions. It was 13.5 years ago. It was September 2011 when we first met with the extension concept. I mean, in 9.1.0 release. The title was, the commit was packaging of external objects. And then I would like to give a tribute to our lovely Simon Rickson here. He said, it makes it easier to add and remove plugins, data type, functions with minimum fuss, and without needing to compile things yourself. So this was one of the main motivations of adding extensions to Postgres. And then, as I told you, contrib modules became extensions, but they are still in the contrib directory for lots of historical reasons. So how everything is done, there's a control file. For every extension, when you install an extension, there is a control file. And it does the checking, dependency checking, with the control file. So basically, it's the extension owner's responsibility to control the dependency. So what was dependency? So let's say if you want to use PG weight sampling extension, it requires PG set statements, right? So it means when you install that one, the other extension must be installed as well. I'll get there. It's basically C code. There was a discussion about this a few hours ago, like not in one of our talks, but there was a discussion about this. We treat the C code extension as the first world citizen, and then the others as fifth world citizen, whatever the word number is over there. And there is a solve file, mostly. There are some SQL commands, control file, etc. So as I told you earlier, there are lots of extensions which are included in the Postgres tarball. So there is a list. By the way, you will be able to find the video recording online if you are taking notes on SCaLE. And the presentation will be available on my website. If you Google, you will find it in some other conferences as well. So I think I gave the same talk in PG Day Med in December. So you should be able to find the slides as well. So yeah, back to control file. So if you have any questions, please raise your hands. I'm happy to take any questions, but again, I will have a session at the end of the talk. So control file control file includes a few properties of the extension. This name is extension name.control. So that control file currently as of Postgres 17, this may slightly change maybe later on, but it must exist under the extensions directory in the Postgres installation. So if you are using RPMs or Debian packaging or some other Windows packaging, macOS packaging, it doesn't matter. There's a separate directory, and Postgres looks there for now. It may change in the future. Anyway. And they must be separately available for every Postgres major version. So what does it mean? So if you're running Postgres 15, and if you're using Firebird FTW, for example, you have Firebird FTW for Postgres 15. But if you want the same extension for Postgres 17, you need to install the binaries or whatever, whatever required, or files, I should say, for Postgres 17. So they must be available for each Postgres version separately. You cannot use an extension built against Postgres 15 on Postgres 17. Okay? So this is basically often handled by the package maintainers. So if you are using one of those PGDG repos that I mentioned earlier, like AP3 repo or PM repo, they are just mentioned anyway. Anyway, I'll get there again. There is a slide for that one. And then if there's a dependency tracking, it's done in the extension control file. For example, this is the H3 Postgres control file. There is a line that starts with requires. It says H3, Postgres, and Postgres raster. So to be able to use this extension, you need the other extensions as well. Okay, I mean install. That's easy. When you create, I'll get there. When you say create extension, and when you say cascade, it will bring up those dependencies if available, and then install them for you. But if available, it shouldn't be a problem in many of the cases because the package maintainers already take care of those dependencies for you. So there are some SQL scripts, and there are some installation, upgrade scripts, and also uninstallation scripts as well. So they are under the extension directory for now. So if you want to see the list of Postgres, all the available Postgres extensions, I think this is misleading. I mean, this view is quite misleading because PG available extensions means available on the instance. So it doesn't mean all the available in the world. Okay? So it means so if you want to install something, if it's there, then you can install that one. It's PG underscore available underscore extensions. And then there's another view called PG available underscore extension versions. They are the versions of the extensions available over there. So the first version of this talk was 5 minutes. 5. Very original version. It was a lightning talk in, as far as I remember, 2 years ago in New York conference. And it was about a packager struggling for doing extension packaging because I'm actually, I'm a community person. I get paid for the community work. I don't do anything else. So it means all of my life is actually based on this stuff. So that's where one of the problems start to arise because they are everywhere. They're on GitHub, GitLab, likely, and then Ostgeo, Gitea, and then PGXN, and then SourceForge, and then Postgres Git repo. I'll get there. I'll skip there. Sorry, that one. PIPI. There are some extensions over there. Some extensions, they have their own websites. They are not in any of them. There are some on big buckets, and then there is one more. Laptops. Yeah. Some people do not even share the code on any Git repo or SVN or CVS, whatever, I don't care, repo. Yes, I was serious when I was talking about an extension developed on a laptop. So, and then this is a real-world example. I'm not going to give the name. I don't want to point out to an FTW developed by someone which connects to a database called D, start with D, but I'm not going to give the full name. This was on 2018 on GitHub, but then there is a version which has been released last year. So what I did was, there is no recent commit, so I also order. I asked order, please show me where the source code is. This is what I got. They said sources and a zip package included. Okay, thank you. Well, I was looking for some other reasons, but like Git repo and etc. And I asked the same question, And this was the response by the extension owner. He said, your tone, this is his typo, seems that you think you are my boss, which you are not. Okay, I'm not your boss. I'm just a poor Postgres packager who's trying to make your extension usable to the community. Okay. So we have another problem. Is this all? No. Let's move on. Then we have to support multiple platforms, right? Because sometimes then suddenly Fedora 41 renames a package, so our extension stops building and also running. So we have to write an if condition. This is the old version, but you get the idea. This is only available in 39, and this is different in 40. So we get 2 lines for this one, the same dependency. And it's different on Red Hat 8, and it's different on SUSE. Right? Please.
Is this the control file syntax?
So the question was, is it the control file syntax? No, it is the RPM spec file. It's the our stuff that does the dependency stuff while building the extension. So, you know, everyone has a great idea, right? We are in the open source world, right? We have a problem. We have a problem that we all have great ideas. And we want to develop our own idea without, I mean, of course, we could integrate our idea to an existing software, but why? I mean, I need to have a separate stuff. That's pretty much welcome. That's why we have billions of window managers on Linux, but only 3 of them are being used, mostly. Users say, yeah, that's a great idea. Okay, so it works like a charm. Let's deploy it to the production. And we deploy that great extension, that great idea to production. And then, okay, now there's a new Postgres release and it doesn't compile, right? Because upstream, Postgres upstream change a header and or change the signature of a function, so it doesn't compile anymore. That's right, that's doable, that's okay, right? So we expect the extension orders to follow that one, and that we expect for, I mean, even I do expect after like 25 years working with 27 years working with Postgres, I still, in a human way, expect them to follow up the changes and make the changes in the core. And then, as the packagers, like mostly me and Christoph, the RPM, the APT packager, we pester them. There's any Postgres release that it doesn't compile. So users complain, packagers complain, and then developer says, no response at all. And then just a week before or a few days before the release, hey, Postgres 17.0 will be released next week. Can you please do something? Users say, okay, well, 17.0 is out. Please, we want to upgrade, but we can't upgrade. Knock, knock. There is nothing from developer. So basically, non-responsive maintainers is a big problem. I mean, as I told you, I would love to show you all the great extensions and how extensions are great in the Postgres community, but they're not. I mean, they are great, don't get me wrong, please use them, but we still have some problems. So my point is make sure they are well maintained and you can access, or something is doable anyway. So it's a major problem. You have something which you use in production, you are happy, it's a great feature, but it gets stalled because you cannot upgrade because the developer cannot do anything, or they don't accept any patches. I may give you an example about that one, which I won't give the name, but yeah, recently, yesterday, they released a new version which works against Postgres 17. Like, okay, we could have waited 4 more years until 17 is end of life, right? Some good people send a pull request, but those are really closed. You can fork, of course, but why would I fork? Just review the patch. Someone wrote the patch, just review and commit or reject or do something. So it's not good for the users. So people use Postgres because Postgres is awesome. I have a tattoo. I haven't used any other databases, except I use that database called their SQL or MySQL, whatever, because I was married back then. So my wife has a website with WordPress. Yeah, so I had to use MySQL, but that was enough. I got divorced anyway, so. Because I couldn't stop using, that's the only way that I found to stop using MySQL. Anyway, I'm kidding. So it's not good for the users, it's not good for the community, it's not good for the packagers, right? Yeah, I may be paid for full-time for packaging it, but it doesn't help me at all. So as a packager, that's me, so how is my life? Oh, sorry, that's the wrong slide. Sorry, sorry, wrong slide, sorry. Sorry, someone hacked my slides. Anyway, yeah, sometimes we do some actual work. Yeah. Yeah, so I can easily talk about espresso martini doesn't have martini, right? That's a valuable information. Many people think espresso martini is contains martini, but it doesn't. Like, it's a great information as well, but you don't have to use Postgres to know this information. Anyway, so it's a lot of work. We have apt-based distros, RPM-based distros, Windows and macOS, basically. And then we have some other, like Gentoo has a nice packager nowadays, which does the packaging stuff for Gentoo. With Gentoo and package, it's, I don't know, something else. Anyway, so let the breakage begin. Let's start breaking, right? I love breakages. So there's a Postgres release, and there is a new GCC version. So, in every new GCC version, there's a new warning, or there's a new compiler error. So we expect also the extension orders to follow up with the GCC stuff as well. Do you think that's enough? No, because then we have new LLVM version. In each LLVM major version, there is something to track. And if you are using Reddit or one of its derivatives, I'm sure that you already know that they release a new LLVM and GCC version every 6 months. So in every 6 months, we are broken. So let me tell you how broken we are. Reddit loves us. You know, we have lots of good relationships with Reddit since forever. And to do us a favor, they release their minor versions, say 9.5, 9.4, 8.9, whatever, one day before our new minor release day. So basically, they expect us to rebuild everything in a single day from scratch with the new LLVM and everything. Thank you. So see, there's another problem. So you expect it to work, but when you upgrade, it will be broken. It's not broken thanks to the packagers or other people working in the community, but that's it. So then there's a new dependency version. So this new extension versions only works against something which is only available in Fedora 45, which has been which we released 2 years later, right? So it's not that easy. So for every for every Postgres major release, before every Postgres release, we start a new wiki page, which lists, actually it's a Hall of Shame, which lists all the extensions that doesn't build or work against a new major version. And believe me, the first months are crazy, because nothing works. Fortunately, this in the nowadays, it's much better. But this is how we do. This is how I contribute to GitHub. Ping, 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 ping. Just as I told you, these are real-world examples. I'm not making them up. And unfortunately, to be honest, so the same content was about 14 or 15 extensions. I don't remember the actual number, to be honest. When Postgres 17.0 was released, and there were some major extensions out there, and developed by the Postgres companies or cloud companies that support Postgres. Okay, I mean you expect them to provide more up-to-date support to the extensions. Like I mean I can give the names. It doesn't matter at that point. But all the Postgres companies and all the cloud companies, I expect them to do some timely releases. They don't. And then these are the only 2 extensions left for now, but we still have 2 for Postgres 17. And then there are some other nice extension orders. So as Magnus stated in his talk, which was the first talk today, we have daily snapshots, and then we have betas, and then we have release candidates, and then we have final release, right? So basically, when we have beta, we are more or less in the freeze section. It doesn't mean freeze, but we are more or less in the freeze section. So I asked one of those FTW orders, which start with SQLite, and they said, please, can you please add support for Postgres 17, because it's already in RC at that point. So they say, it works fine, the source code is not published yet. We plan to release after Postgres 17 was released. Why? Why would you release something after Postgres 17.0 was released? It's not good for the users. This disrespect for the users, from my point of view. So what did I do? Espresso martini? Guinness? Yeah. I go to Chicago like every other month to listen to blues because I don't care. And then I send a tweet. Please complain to the extension orders, not me, because I just built the tarball. I cannot do anything else. And I gave the link that I showed you. Go complain to them. Don't complain to me. Don't create tickets in our issue tracker. So let's start with the installing the extensions. To install an extension, you should first need to make it available on your operating system. Currently, it's being on Linux. It's being done with the root user. So you have to have the root user because you need to write under the USI directory to be able to install an extension. Okay. So this is the only way currently, again, for an extension. So you can install the binary packages, or you can compile from the source, or you can do the other installation options. Some of them may require them to be added to shared preload libraries to be able to be installed. No worries, even if you don't know, the extension will let you know. In this specific case, if you want to create an extension called Citus, it will say Citus can only be loaded via shared preload libraries. So it tells you you cannot create the extension because it's not available in shared preload libraries. That's good, right? Which is great. So you go there and make the change, restart the server, and then start using Citus. Great. And then they may require dependencies to be installed, but as I told you, the package maintainers deal with the problem, so you shouldn't be worried about that one at least. So you can create the extension. You can create the extension, let's say Citus. That should be enough for most cases. Or you can use a cascade if the extension has some dependencies, which is OK. And or you can say install it to a specific schema if you want to restrict that functions to a specific schema. By default, I think they're all installed in public schema. Oh, that schema name is actually also written in the control file. So basically, the extension knows where to be installed by default. And as I told you, if you want to install H3 Postgres extension, it says required extension is not installed, and it gives you a hint. So if you do the hint, it will install the dependencies for you. So as long as you know as long as you see the procedures and you know the procedures, don't worry. You don't have to memorize. Postgres is going to tell you how to do things. So it's actually usable from that point of view. Or just read it. This is what I did recently in yum.postgresql.org. This is one of my major projects that I have done in the last few years. So if you go to yum.postgresql.org/extensions, it's all actually listed. There's a link at the top left for that one. There's a new website there's a page called Extension How To. So basically, for every extension that we have as an RPM, I think we have more than 130. I may be wrong though. For about 100 extensions that we have, I wrote documentation how to install, how to configure, and some parameters that could be useful for you, some GUC parameters, right? So that's a basic starting point of view. That website could be your basic starting point of view. First of all, if you want to know how an extension is installed, or my main motivation was, if you want to learn which extensions are available in Postgres. Because one of the most common feedback that I got about this website was, I didn't know that such feature exists for Postgres. So let's make all of our lives easier and read it and use it. Updating an extension is a challenge. It's a big challenge. First of all, you have to install the updated extension. When I say install, I'm talking about installing via the package manager. Windows or macOS or RPMs or apt package, it doesn't matter. Install the extension, updated extension. So then we have a problem. The problem is the running code, which is loaded by Postmaster or Postgres, whatever, is still using the old one, but on the file system, we have a new one. Currently, there is no way to overcome this problem. Maybe in the future, we can fix that one. But the unwritten policy is just please restart your instance or whatever, update your extension as soon as possible with alter extension update. And which some extension may not need this, because if there is nothing to be updated, then that's fine, by the way. So you will get a message like this. Version is already installed, so there is no upgrade path, which is fine. So there are. I told you about this one. Uninstalling an extension is is another thing that's done easily. You just say drop extension. So when you want to uninstall an extension, you can say drop extension, but still. You may want to remember how you installed an extension. So, for example, as I told you, for Citus, if it is in the shared preload libraries, you have to remove that one as well and restart your instance. Okay. So you remember how you installed? Just do the reverse way while uninstalling an extension for the safest option. So we also have the cascade for managing the dependencies. So let's talk about the favorite extension, which is going to be one of the last parts of this talk. PSQL is the only default extension in Postgres. So it's an extension, but it's installed by default. You can argue that it's not an extension, but it is technically. And then we have PL Python, we have PL Perl, we have PL Tcl. I was told not to talk about PL Java today, but I will. There's PL Java as well. But there is, I'm not saying you can use it, but there is PL Java, PL Lua, PL Bash. So if you are using some shell scripts in Postgres, it's doable. PL R is great. It utilizes R language for statistical purposes. Yeah, there is JavaScript, but the comment was there is also PL JavaScript. The reason that I didn't mention it here, to be able to build PL V8, it's called PL V8, you have to download the whole internet. So if you want to build them, it downloads something from there, something from there, something from there. As far as I remember, it's like a few gigabytes to download everything, so I'm not doing this. That's why you cannot find a pre-built package of PL V8, which is not an extension, but not their programming languages, but we have PL PGSQL check for checking your PL PGSQL code, and PL Profiler for also profiling your PL PGSQL codes. And we have Postgres. I was speaking to Magnus on our way to Pasadena yesterday. What's your favorite extension? Everyone's favorite extension is PG statements, right? Other than, even if you don't use it, we also respect the Postgres maintainers because they are defining the standards in the JS world. They are doing an awesome job while working on Postgres. So it's a JS extender for Postgres, and the website is, it's an extension. The reason of this line is, I mean, it's too big. I mean, it's a great, it's not just a small extension, it's a big one. And I love PG routing. Everyone I mention about Postgres, I also love talking about PG routing. PG routing extend Postgres. So it's an extension to an extension, basically. It's with routing and network analysis functions. It has lots of routing algorithms. It's available in many packaging formats. It depends on SCaLE and Boost. That's our problem. Well, sometimes your problem as well while installing them. And this is the website. PG routing is a great way if you are to add some routing. I think there's at least one user that's shaking his head. I can see it from here. PG routing is great. PG statements. It's a must install for everyone. If you don't agree, just agree. It should be installed by default to every Postgres database that you have.
Why isn't it by default?
Why it is not there by default? As I told you, going from contrib or extension into the core is another process. In the past, there was a reason that it had some overhead, but it's not there anymore. So yeah, and you know we have to make money, right? yeah. It's just how do we have a problem? You know, as a Postgres consultant, we have to make money. So we have a problem. How can we solve this problem? Please install PG statements first. And we made some money, right? yeah. So you know, in the AI world, you know, I was checking the talks. Everyone talks about AI, right? And so I have to talk. I was told to add some slides about PG vector so that I can get paid. I'm kidding. I'm not serious. So PG vector is a vector simulated search for Postgres. It stores your vectors with the rest of your data. There is a PG vector talk, I think, tomorrow, right? Yeah, tomorrow. There's a PG vector talk, so you can please see them. PG Partman. It's one of my most favorite extensions. Partitioning in Postgres is awesome. I love partitioning in Postgres, but there's a problem, it's not usable. I mean, it's usable in terms of from user point of view. I mean, the underline is great, but to maintain creating new partitions, maintaining them, and like doing some data aging, etc., is something. So everything is handled by this great extension called PG Partman. I mean, it's like a PG statements for me. For everyone who's using PG partitioning in Postgres, for every installation, these are default because there is nothing else that you can do. Otherwise, you can write your own scripts. Of course, you can maintain, but this is by using this, it's done everything by default. Just use a cron job, and it's done. Everything is maintained automatically. It works great. Just you have to read a few examples for sure, but then the rest is just easy. And the good thing is, it's being actively developed. It's very actively developed, like very actively developed. So feel free to use it. Citus, it's horizontal scaling for Postgres. It does sharding and replication. It's a great feature if you want to scale Postgres horizontally. It's 100% open source. I think it's developed by Microsoft, so it's a great addition to Postgres. And then we have time SCaLE. So if you are using the time series database, that's an extension. Some part of it is open source. Some part is source is open, but not open source licensed. Okay, so there are two parts of time SCaLE. Just to let you know. And there is PG Audit. PG Audit is it does the auditing for Postgres. So if you are using Postgres and if you need some auditing, PG audit is the only way of doing things. And I didn't mention it here, but it kills your log files. So there is another extension called PG audit log to file, which actually does the other logging work for you. So make sure that you install both PG audit and PG audit log to file to be able to manage the overhead caused by PG audit logging. And there are some foreign data wrappers. Foreign data wrappers are awesome. This is one of the reasons, I have lots of reasons to love Postgres, because I love the elephant anyway. Seriously speaking, FTWs are great. And these are one of the main great features in Postgres. So you can connect to Postgres easily, and then Oracle. You can connect to your Oracle database and get data from there, actually read and write. TDS FTW is for SQL Server and Sybase. So basically, you can connect to those databases within Postgres. You can connect to MySQL and MariaDB with Postgres within HDFS to the Hadoop file system. Mongo FTW to that Mongo database. SQLite FTW, if you are going to connect to SQLite from Postgres, that's also doable. Firebird. Both of these two, JDBC and ODBC, are generic drivers that you can connect to any JDBC or ODBC data source. That's doable within Postgres. OGR FTW is for GIS users. PGBouncer FTW is awesome. If you are using PGBouncer, it simplifies the management of or viewing of some views of Postgres, PGBouncer. And then File FTW. File FTW is the CSV files that you can manage, not manage, but you can read the data from Postgres. There are lots of extensions in here. I mean, Postgres is very extendable. I mean, everyone like HLL. This is one of those interesting extensions. H3PG, HyperPG. If you want, HyperPG is used for creating hypothetical indexes. So if you want to create if you are thinking about creating an index, but if you are not sure about its impact to the performance, just use HyperPG, create it like in a hypothetical way, test your query. If it works, then you can create the index, right? Which is great. We have Multicorn. It's like FTW, basically. You have PG cron. It's like PG agent. Like you can use crons within Postgres. These are the Oracle compatibility stuff. You can run some background stuff with Postgres. You can, I mean, there are lots of PG repack is another de facto that repacks your tables. There is no alternative, so it's not the best, but there is incremental view maintenance in here. PGNet contains the internet and gets some data. There are lots of examples. PG temporal tables, it's like Oracle temporal tables. There are lots of things that you can use with Postgres. There are PG read-only, which makes your database read-only. PG hint plan. So just to let you know, which was spread, I think, in the last couple of weeks with LinkedIn, there is no query hints in Postgres. Okay, there is no query hints in Postgres. Some people claimed, I learned that some people claimed that there is Postgres hints are available since Postgres 12, and those people actually show the fake code in LinkedIn, which is what I was told. But you can use some hints by using this extension, and don't. Because the original approach of the Postgres project is, don't think that you are smarter than Postgres. If you think you are smarter than Postgres, it means you found a bug. Just let us know and we will fix it, right? This is a like very modern way of dealing with open source. PG statement rollback is like Oracle's statement-based rollback feature. PG memcache is memcache for Postgres. PG Sodium is crypto functions for Postgres. PL debugger, I mean, there are lots of extensions that you can use within Postgres. So I think I have 5 minutes or? Yeah. So first of all, thank you for coming to this talk. I appreciate it. I came from Istanbul and London all the way to here. I never regretted this in the last 3 years because it's lovely to see the great people are coming to listen to Postgres talks, and thanks for joining us. Just to let you know, we have a Ask Me Anything session at 5 p.m. as far as I remember-ish, the last session. Ish, I was told. So please join us because that will be Ask Me Anything, not me, but Ask Us Anything session. So if you have any questions about Postgres, please join us. So if you have any questions, it's the right time for them. Please.
Sorry, if you have a question, please wait for the mic. We are recording the room, so just a moment.
Devrim, you mentioned that PGSS in the past had overhead, but
I can't hear you.
Can you hear me now? Better?
Yeah.
Okay. You said that PGSS in the past had overhead, but then you mentioned in passing that that's no longer the case. Could you
So which
elaborate?
one? PG?
PG stat statements?
Yeah. It used to have, I mean, in the very past, like 15 years ago.
So should I understand that there is no overhead?
Nothing is no overhead. So the question
That
is,
was a trick question, right?
So the question is, PG statements has an overhead, but it does, so do I mean that it doesn't have an overhead? It's negligible. Of course, everything is an overhead, but it's negligible nowadays in the last 10 years or so, maybe more. Follow-up? Sure.
So I understand that in the past, the overhead was correlated to obviously the amount of queries that are being issued. Is that still the case? Is that still a correlation between the heft of the workload that Postgres has to incur and the overhead from Postgres?
I think, I don't remember the history, to be honest. Does anyone know the answer? How we got rid of the overhead of PG statements?
I won't pursue, thank you.
Okay, sorry. I mean, I remember a few things, but they are vague. Like I told you, it's been 15 years or so. There is another question from the gentleman over there.
So I have an extension I want to release. What am I supposed to do here? I've got to support 5 different versions of Postgres, 4 different operating systems, different versions of these operating systems, 2 different architectures, ARM and x86. Should I just make everybody compile from source, or is there some other option?
So you're not tequila. You cannot make everyone happy, first of all. You don't have to support all the Postgres versions. I mean, some people start with, say, as of today, I'm going to start with Postgres 15, 16, and 17. That's all. Then it makes their lives easier. And yes, you may have to worry about some GCC versions as well, because if you want to say, I want to support Red Hat 8 and Red Hat 9 and upcoming Red Hat 10, that may be a slight challenge. May not be. I'm not a hacker, so I don't know the actual answer. But yeah, you may have to support multiple compilers, or you may easily say, I'm not going to support anything below GCC 11, up to you. And then for the platform support, yes, you should support ARM and x64. I'm not going to say you should support PPC, PowerPC. That's not required that much. But yeah, you should do this. So what should I do? Just publish your code on internet. Make sure that they can be compiled. But don't worry about the dependencies. That's our responsibility. But make sure, so if you are depending on some zlib version, which is recently released, it means we cannot push the package to Red Hat 8 or Red Hat 9 or some Debian 10 or whatever, old versions. So it's up to you, actually, as a package maintainer or extension maintainer, which operating systems or which distros you would like to support. Then the rest is our problem, or in terms of the packagers' problem.
Okay, so let's assume that I take the time to write a script to do 16 different versions of this thing. Then how should I distribute it? Just let people download it, or do I need to do RPMs, or what's the best way to package it?
What many people do is go to postgresql.org, submit a news item. I can suggest you submitting a news item saying that I wrote an extension and it does this for you, and here's a download URL and something. And then you can also contact the package maintainers. They are all well listed on the internet. You can contact me or Christoph or anyone about the packagers, and then we can package that one for you.
Ah, you're going to do it for me.
No, just let us know. Yeah, that's why what we are paid for. And then it will be distributed via our official channels. Or, sorry, some people do their packaging with Fedora and EPEL or Debian itself without working with us. That's okay. But I would prefer we doing the actual job anyway.
All right, thank you.
More questions? Just a second.
Hi, I noticed that we have a lot of different languages coming out for PLs to write different extensions, and I've heard people writing extensions in Rust. For things like Golang with CGO, what defines like what languages get to be Postgres extensions and which ones don't? It's like our team, like they don't know really anything except like Go and Java, basically.
Yeah, I was hoping no one would ask the question. To be honest, that's why I didn't include anything about Rust and Go in my slides. So I'm talking from the packaging point of view, first of all. I'm not talking about Postgres itself, because you can write any extensions with Postgres, against Postgres. Postgres doesn't restrict you using any language, right? You can use Go, Rust, C, C++, whatever what's available for Postgres. That's okay. From packaging point of view, Rust and Go requires lots of extra work so that they can be available in the distributions, because of how Rust works and how Go works. So I would encourage you not to write anything on these languages. This is not a language discussion, first of all. I'm not saying anything negative on these languages. Okay? I'm not a hacker. I don't code. Don't get me wrong. I'm not talking anything negative about any languages. As I told you, I'm speaking as a packager. That's why there is no package, RPM package with Rust and Go in both APT and RPM repos in the official Postgres repos. Again, it's not about language. It's about how the languages work and how we create the extensions. But again, there's PGRX for Rust, which does the major work for you. You can do it, you can distribute it by yourself, but from the packaging point of view, it's too hard for us. I hope I was clear about the language. I don't want to offend anyone. Right, thank you.
All right, so a question I had was, some of us are forced, I say forced with quotes, to use a provider like AWS RDS, and we're using MySQL or Postgres, Aurora Postgres. Something that I've been trying to implement was authentication with Kerberos instead of using localized database users. And unfortunately, I think it's PG_80 map or mapping, I can't remember the full extension, only has a version 15.5, not 15.4, not 3, no 16, not 16. It's not great. So what do we do as users to try and, I don't want to say push the maintainer, but this is strictly coming through. Yeah, exactly. Yeah, because I would love to use Kerberos and not use IAM. So, yeah.
Or, it wasn't your question, but you may sometimes, we can extend your question like, I cannot find my favorite extension in my cloud provider. Then don't use cloud. Then sorry.
When you showcased some of the popular extensions, I expected to see something about backup and restore, and you didn't mention any.
Are there any extensions which do the backup and restore thing?
So
PG Backrest isn't an extension?
Right.
Yeah.
I was surprised to not see it in the list. Is that still the
because it's not an extension. It's not an extension.
Oh, it's not?
It's not. I mean, when I say extension, when we say extension, it's called create extension type extension. It's not, I mean, we have lots of software around Postgres. Like, yeah, for example, PG Backrest is our de facto tool for taking backups of Postgres, right? But it's not an extension.
Right, makes sense.
Yeah, yeah.
Any more questions?
All right, so one question. So you encourage use PG Apartment, and you are not the only person who is encouraging it. And I deal with the partition tables a lot, so it is a pain. But my question is the situation with core Postgres is so hopeless we should not expect significant improvement in partition maintenance in the next X years? Because I was honestly hoping that we will have a little bit better support.
I do agree, but again, if we have a patches are welcome. Until then, PG Apartment. Someone needs to write the patch. I mean, that's the problem. So I think we are over time, or? Okay. Thanks for coming, and hope to see you in the next few talks. Bye-bye.
Thank you, Deborah. Really appreciate it.
If you don't mind, I have a tradition. I always take a selfie with the people who attend my talks. If you don't want to be in the picture, you can leave the room. Otherwise, I will take a just quick selfie, if you don't mind. Okay? Thank you. Thank you. Bye-bye. Thank you.
Yeah, thank you. Appreciate it. We're going to give everybody just another minute or two to show up, so bear with us. We'll start promptly. All right, everybody, welcome back to Postgres at SCaLE 22. Our next speaker is Hamid Akhtar, who is been working extensively with PostgreSQL over the past 12 years, currently working as a principal software engineer with PG Edge. He's going to talk to us today about keeping your Postgres replication healthy. So, Hamid, please.
Thank you. Thank you. Hi, my name is Hamid, and we're going to discuss how replication can be kept healthy. It's a challenge, pretty difficult one, but let's see. Just a bit about myself. I don't have a tattoo of Postgres anywhere. I've been involved with the Postgres project for more than 15 years now. In different capacities, I've worked with different organizations, with EDB, with HiGo, Percona, and now with PG Edge. There was a time when I was responsible for releasing the official Postgres installers on all supported platforms, which were pretty hard at times with working with different operating systems and architectures. More recently, I'm working on an extension for an active-active replication solution, Spock, with PG Edge. Prior to that, I've contributed to PGTDE, which is being worked on by Percona. PGStat Monitor is an observability extension that's kind of like a big brother to PGStat Monitor, and it offers more features, and actually it caters for the deficiencies of PGStat statements, where the observability challenges come up in its statistical data. So here's what to expect. We're just going to take it gradually and go through replication and how we then look into the conflicts in replication. So we'll start with MVCC and see how that plays a pivotal role in causing replication conflicts. We'll move to streaming replication then, and then the conflicts in streaming replication, moving on to logical replication after that, and see what kind of challenges we face up with logical replication, and finally, how those challenges can be then solved with Spock. That's an extension that we're working on and we believe has come of age recently with a lot of changes been done in it. So I think the first question to ask is, why do we need MVCC? So MVCC is essentially there for multiple reasons. One is that it allows multiple users, multiple transactions to run at the same time without blocking one another. So reads would not block reads, reads should not block writes, and we just want a smooth operation of the database system where multiple activities can happen simultaneously without blocking one another. So internally, what happens is that Postgres is going to maintain a multiple version. So it's going to maintain different versions as you make changes to rows and data. So each backend, as it makes changes, is going to have a new version of that row. And that's the way Postgres manages it. It needs to know actually when it's making those changes, it needs to know about the visibility of those changes. It needs to know the visibility of the changes that it should see. So there are snapshots. Snapshots are really, it's nothing, it's just a couple of lists which are there are two values, which one defines the transactions that have gone before itself. So anything that has happened in the past, then you have the transactions that will happen in the future, and you'll have a list of currently running transactions. So that's its way of identifying its visibility to different data or rows or tuples that it wants to access. So really at the core of it is to optimize reads and not block the writes. So it's done through a detailed locking mechanism. The side effect of this is that you'll end up with bloating. That's a typical issue when Postgres, when you have data getting bloated over a period of time, you have tables that are going beyond a significant size, more than the data itself that's valid in the table or the indexes. So it causes a lot of challenges, but it does have benefits in terms of how it parallelizes the access to data. So the thing about multi-versions is that we need a way of identifying transactions, and comes in transaction ID. That's a 32-bit integer that is basically keeping track of your position in the timeline, so to speak. It's not precisely that, but it's more about an identifier of the transaction that's currently occurring. So you are assigned a transaction ID once you start making changes to the data. Before that, there is no transaction ID assigned. So as long as you're doing a read, you don't have a public transaction ID assigned. You'll have a transaction ID assigned, but that's local to your backend. Nothing that's public. So the moment you make the first change is when you're assigned a transaction ID. This transaction ID is the one that is then, as I discussed in the snapshot, so this is the transaction ID that other running transactions will see, maybe in their snapshots, maybe if you've committed, would see them as a past transaction or as a future transaction for some. So with data, you need to obviously control how you access it. Postgres does it in different ways. There are different types of data internally that Postgres has to manage. From a user perspective, you have user logs, you can have advisory logs, you have explicit logs. But internally, Postgres server manages 3 different types of logs. You have spin logs. Spin logs are really for quick access. You are meant to hold that log for a very, very brief duration, maybe say increment a value, check or test a value, and that's pretty much it. It's more for atomic operations. It's not for any long running function calls where you want to hold a spin lock. It's busy waiting. So while you're holding this lock, others would be busy waiting. So you're not meant to hold this for long periods. Then you have lightweight locks. These are really at the core of the whole Postgres, and these are how you protect larger data structures in Postgres. And finally, you have regular locks. So what you do not have with other locks and you have with regular locks is deadlock detection. Deadlock detection comes in with regular locks. Spin locks don't have it, lightweight locks don't have it. But when you look at regular locks, internally they're implemented through lightweight locks, and it goes through a whole procedure of acquiring those locks or waiting on those locks, or maybe then identifying a cycle and goes through and then goes through a deadlock detection process. So those are implemented through this. So why am I touching all of this? So when we look at a tuple structure, there are hidden columns, there are hidden metadata that a tuple has that we need to remember. It has quite a few details other than the tuple data itself. The tuple data obviously would be significantly larger, but still we'll have the xmin, the xmax. That's the minimum. The xmin really refers to the transaction ID that created this tuple, and xmax refers to the transaction ID that deleted this tuple or updated this, or where you have a new version of this tuple. Xmax does not always refer to a valid transaction ID. A transaction that have updated this tuple and aborted might leave a valid Xmax for this tuple, but it's going to mention some of that detail in the info mask, where it's going to mention about the visibility, whether the Xmax is valid or not, which then defines the visibility of this tuple. So if you have a transaction, if you have xmin, obviously with any tuple that's created, you'll have a valid xmin. And then in some cases you might not. With an inserted tuple that's aborted, you might not even have a valid xmin. But say you have a valid inserted tuple, and then you have a transaction that comes in that deletes it, but aborts the transaction. As it deletes it, it acquires a lock on this tuple. It's going to have its own transaction ID in Xmax, so its XID will be in Xmax, and it will also just lock this transaction so nobody else can while it's updating it. So that's how it's ensuring that concurrency is managed and the updates to the same data are basically managed by a way of lock system. So in comes streaming replication. So I'm just building up to the components of how replication and all of these different components basically feed into the replication conflicts for streaming replication and logical replication later on. Write-ahead log was introduced in 7.1 very early on, 2001. Before that, every commit was essentially writing the database to disk, which meant that it was causing all kind of challenges with inconsistencies, with partial writes, with whatnot, and the performance obviously was pretty horrible. There were essentially two options whether when you want to talk about crash recovery, either you have a wall, a write-ahead log, or you have shadow copy. Shadow copies are when you maintain a copy of the data pages separately as you make those changes, and you maintain a list of valid data pages. And finally, when a transaction commits, you replace the root of that chain to point to your valid chain now. The benefit of shadow copy is that you never need to recover. You always have correct, up-to-date data. You don't have partial writes. You don't have uncommitted transactions. You don't have in-progress transaction data. With write-ahead log, basically, you're writing to a wall stream. So all the changes are going into a wall stream before they make their way to a page. So tables are not updated immediately. Wall is what ensures persistence on disk first. So it's durability and consistency. That's what wall is assuring. Implementation of this actually then obviously also optimize the performance, because now you have just one process that's writing to disk. You have a smaller footprint that's being written per transaction, so it becomes much simpler now. The other thing to remember about wall is that the transactions are interleaved. So you have one transaction that started writing something, so it inserted a transaction. It has not committed yet. Another transaction comes in. It will write something as well. So it's basically the transactions would be interleaved. They're not going to be like one transaction then followed by another transaction, not necessarily in that way. So replication in Postgres evolved over time. The first component of that streaming replication was WAL. It was followed by WORM standby lock shipping, where the chunks or the wall segments were being shipped out as a package. The challenge with this was that this was asynchronous and you still could have data loss. You had your timeouts, you have your thresholds for how much wall data you can maintain, but still there was that possibility that you can always end up losing that much data that's not been sent over. 2010 9.0, you had your hot standbys. With hot standbys, you have two core processes that came in. You had wall sender and wall receiver process. Now, these are critical in streaming replication or in replication in general, wall sender in particular. The responsibilities was not just about picking up the data for wall sender, sending it out, but for wall receiver, it was also about writing that data, flushing that data to disk, and then just basically pinging the startup process to start applying those wall changes. Logical decoding and logical replication came in 9.4, so this is very different to how streaming replication works. Streaming replication has three core processes. You have your startup and wall receiver, you have the wall sender. Wall receiver and startup on the standby server, the responsibilities are really, wall receiver is going to ensure that the wall that it receives from the wall receiver is basically going to be flushed onto the disk. The strategy of how it confirms that really depends on the confirmation or your synchronous commit, basically GUC. Startup was an old process. Its responsibility is really to recover. So even after a crash or a server crash, your startup process will take up any wall records and it's going to apply those until it reaches a consistent state. So you have these three working together where the connection gets established by walls. So the connection is basically started by wall receiver. Wall receiver initiates a connection request. Since it has connection information, it's going to send that connection information or it's going to attempt to connect to the primary server. The primary server is going to spawn a wall sender process, which is then going to establish a TCP connection with wall receiver, and then you have a connection established between the two. As the transactions commit, there are a couple of functions that basically essentially ensure that wall data is written is xlog insert and xlog flush. These are the two core functions that are responsible for ensuring or flushing xlog data to disk. When this happens, wall senders are woken up. So when you're writing a wall, basically a wall record, you signal wall sender process, and the wall senders wake up and they start then processing that data and send out that data to wall receiver. They wait for different acknowledgements. There are three different kind of acknowledgements that a wall receiver, wall sender would wait for, possibly, depending on, again, your configuration. The first one is whether the data has been received or written. The next is whether the data has been flushed on the standby. And the third one is whether the data has been applied. These are the three LSNs, log sequence numbers, which the standby would be reporting back to the primary server. As a transaction commits, it's going to wait for those confirmations. It waits on, basically just sleeps on a particular function during commit transaction processing. In between, to ensure that the communication is healthy, you have a heartbeat where wall sender and wall receiver are basically sending back and forth to ensure that they're aware of one another. Internally, what happens are the functions that are responsible for applying wall. They're really dependent on the access method, so you'll have a standby redo function or a heap redo function. And those are really, similarly, you have functions, redo functions for other access methods as well. But with each, there are two different kind of conflicts that we're going to look at for streaming replication. The first one with standby redo is locks. Overall, when we look at conflicts in streaming replication, there are 5 different types of conflicts. Categorizing them in different categories. Table space is when a table space is dropped or a database is dropped, is when you'll have a conflict on the standby server about a resource that is no longer available to it. Snapshot is when the corresponding row versions are not available. Remember that for MVCC actually ends up creating different row versions. So based on your transaction ID, you will have access to some row versions and you might not be able to see other row versions. So if your corresponding row version is no longer available, you would have an issue and a conflict there. Deadlock and buffer pins are others. Sorry, yeah, so there's only effectively one view in Postgres in the statistics collector, and that's pgstat database conflicts, and that is essentially a counter of each conflict per database. So you'll have one counter for all of these conflict types per database, which does not really give you a lot of information into why this conflict happened, what could have been done to avoid it. You have one other field in pgstat database, but that's again just one field, nothing too informative. To generate a lock conflict, it's actually pretty easy. You start, say, in this particular example, you create a table, fill it with some data. On the standby, you start a transaction as well, and then you access that table. On the primary, you drop that table. Now, what happens is that in streaming replication, you have a wall receiver process. The wall receiver process has a core responsibility of ensuring that it's not lagging too far behind in the wall stream. So it needs to apply those changes, it needs to receive and get those changes applied. It cannot wait for other transactions forever. So it obviously takes priority over other transactions. So it does have a configurable parameter which is max standby streaming delay, which it waits on. By default, it's 30 seconds, I believe. So it's going to wait for that much, and then it's going to effectively kill all of those transactions that are holding those locks. The way, actually internally how it's done is that when on the primary side, when we're running a transaction and we're acquiring exclusive locks, we're actually then also registering those locks in the wall. So the wall gets a kind of a complete list of exclusive locks that need to be acquired to process this transaction. When the transaction commits, that record comes over and we need to apply it on the standby. We start with all the list of exclusive locks that we know are required to apply this transaction. So immediately the server, the standby redo function is going to attempt and it's going to acquire all of those exclusive locks. Now those exclusive locks are actually implemented through lightweight locks. So LW locks in exclusive mode must be acquired. So the moment it's unable to acquire one of those locks is when it's going to wait for this, and then it's essentially going to retry and see after the timeout, it's going to retry and see whether it can acquire that lock again. It knows which processes are actually holding those locks. So if by that time those processes have not released those locks, it's going to kill all of those with a specific signal. And that's when you see this conflict in the log. And pgstat database conflicts gets a value incremented for conf lock field. So yeah, this is pretty much what I just explained. With standby redo, it's going to attempt all those lock acquisitions, and then it's going to fail immediately. It hasn't done any other processing yet. Snapshot conflicts are slightly different. They're essentially triggered by vacuum or hot chain pruning. On the primary side, you have a table. On the standby side, you are trying to access row versions. You could do it with a long-running query that runs for hours, but this is, for example purposes, this is a very easy way of implementing, even with smaller data sets, that you define a cursor, declare a cursor, and you fetch that data from there. So the moment you delete data and you vacuum it, it now needs to do the same vacuuming operation on the standby side. I think maybe in version 16 or 17, they've changed that manual vacuum now also honors the timeout for standby. Previously, when you do a manual vacuum, it pretty much immediately triggers the conflict on the standby side. So the moment you have vacuumed, the wall receiver has received and it needs to do certain operations. A vacuuming is a heap operation, and it needs to basically prune old row versions. So for it to be able to prune those versions, it needs to acquire exclusive locks. And those locks cannot be granted since another transaction is holding a read-only lock on it. So it cannot have an exclusive lock on that tuple. So when it runs out of time, it is going to then obviously not be very happy and end up killing all of those. The challenge with monitoring these is that there's not a lot of information, and all of these are localized to the standbys. So on each standby, you have one row per database where all of these conflicts or different type of conflicts are registered or incremented. But again, there's not much observability in terms of how those conflicts were originated, whether there were queries that particularly caused that conflict, and how you can actually solve that. So there are options when you can increase that visibility. One is to ensure that you have query ID as part of your log. Query ID was introduced in version 14, and the GUC is compute query ID. Prior to this, there wasn't a query ID. It was essentially part of pgstat statements, which used to, for its own observability information, used to compute the query ID for itself. So version 14, it comes by default, it's auto, so it's neither on nor off. The auto setting enables any of the tools like pgstat monitor or stat statements to enable query ID computation. Query ID computation is a little, it's obviously going to use certain CPU cycles. It uses OIDs of objects to calculate a query ID. So it's predictable. It's the same query ID in terms of streaming replication. It will be identical on the primary and the standby side. So same query ID will result in the same query will result in the same query ID. You can also log for recovery conflict waits and see whether it's going beyond deadlock timeout, to see whether it's waiting more than it should have for acquiring those locks. So that's another way of you looking into whether you can possibly avoid this or identify a pattern with these. Long-running queries, obviously long-running queries or orphan prepared transactions or prepared transactions can hold back these locks for a longer duration. At times you cannot see a lot of those details about query IDs or the originating application of a query. So pgstat monitor actually does solve that problem, and you might want to look at it, to look into long-running queries and see whether you can identify the application or the particular query or the parameters of that query and their values. pgstat statements would not show you the parameter values of a query. Finally, you might want to consider rewriting queries. Even a read access to a query, to a table or a tuple would cause a conflict because it would prevent an exclusive lock. So whether you actually need to touch those tuples, that's an option to consider. There are a couple of parameters that you obviously are simple and easy to remember. You have the standby archive delay, and you have standby delay, streaming delay. They serve different purpose. Archive is essentially for recovery. Streaming is when you're streaming the transaction and processing that stream of wall data. Hot standby feedback is a way or is a mechanism of informing the primary that standby is working on certain XIDs, and the corresponding tuples should not be vacuumed out or should not be pruned. The problem with this is that what if the standby disconnects for a while and the information is not passed on? So logical replication actually solves these problems in a different way. It has its benefits, it has its challenges. Logical replication is not a block-based replication. It does not go byte by byte. It does not have block addresses. It's essentially data. It's essentially changes to that data that needs to be shared with another Postgres server. So you have a publisher, you have a subscriber, and you can go either in binary mode or in text mode. The difference is that when you go into a binary mode, it's obviously faster, it's more optimized, but the benefits of having in a text mode is that you can do logical replication completely agnostic of the underlying hardware architecture, or you can go through different major versions. You can also have implicit typecast. So a tiny int on the primary on the publisher could actually be a big int on the subscriber. So you can have that benefit with text mode and logical replication. So logical replication is going to ship out tuple data. It's going to pick up that information and it's going to send it packaged in a message, in a protocol messaging setup. The challenge with it is that inserts are fine. Inserts would not conflict. But when you have an update or a delete, that update or delete requires the subscriber to identify the tuple in its data, the corresponding tuple. So it needs to know which tuple it needs to update, which tuple it needs to delete. And that's where the concept of replica identity comes in. By default, it's just your primary key, but you can also set it to full, and then you can have a full scale update and delete mechanisms. Logical replication, the native does not do sequences. It will share the data of sequences, but it's not going to change or update the catalogs. So the standby and so the subscriber and the publishers obviously will have the same data, but their starting position or the current position of the sequence numbers would be different. And it does not do large objects. It does do toast, but not large objects. Similar to streaming replication, it has three processes. You have the apply workers, and you have the logical replication launcher, and you have vault sender. Vault sender is responsible for sending out the logical message with the data, and the apply worker is responsible for applying that change. The connection is again established by the apply worker. The apply worker, when it starts, is going to send out start replication command, and that's when the publisher will spawn a vault sender, and the vault sender will establish a connection with the apply worker. So logical decoding is the concept of decoding that transaction from the wall into more textual format that can be then interpreted. It's more of an infrastructure where it allows us to write extensions. It allows us to write decoders or output plugins, which can then process it in any way that they wish. So they'll receive that transaction. It starts with when you commit a transaction. So this will not be invoked. This process would not be invoked if you have an aborted transaction. So only when a transaction commits. So that's simple. So there's no noise here. So the moment we have a transaction that's committed, we begin to decode that transaction. we identify the changes in it, and we send all of those to the subscribers. Finally, we'll end up sending a commit message to let the subscriber know that this was the last message for this particular transaction. There are replication slots, which are logical and your streaming replication slots. They're different in nature and how they're processed. The challenge with logical replication slots versus the streaming replication slots is that streaming replication slots will carry data for log sequence numbers to ensure that the wall is retained and the wall segments are not recycled. But it will also, as part of its messaging or a part of its communication with the wall sender, it will also send out XMINs that it still needs to see. So it will basically define XMIN horizons as well. With logical, since you have possibly two active servers, there is no XMIN. So all it has is the knowledge of the wall that it has received, the changes to the point in the wall that it has received, not anything about the XMINs, which means that vacuuming and hot chain pruning can happen. And if you want to ensure that those do not happen, you will have to hack the internal core Postgres server to do so. Logical decoding provides an API interface, looks something like this, and as you can see, there are a lot of functions. The functions essentially handle your prepared transactions, your streaming transactions, your begin transactions, your row filters for origin, etc. So not going to go into more detail into this. So conflicts in logical replication, they're essentially data conflicts. So you have an insert conflict, and this is critical, the information that you'll see in the log. So you see that the first message is that a logical apply worker has started. So replication has started, and then what I did was I inserted the same primary key on both nodes. So I committed a transaction with the same primary key on the subscriber as well as on the publisher. So I ended up having a duplicate key constraint violation. So what happens then? The apply worker has no control then. The moment it receives an exception, the moment it receives an issue, it essentially needs to throw an error and it needs to exit. But it does, before exiting, it does provide us with some information about the position in the wall where the transaction that it was processing finishes, which means that the next position in the wall would be pointing to or would be of a different transaction. So, but the other important thing is to note in the brackets the numbers. Those are your PIDs. You start looking at 592, 592, 592, 592, 941. So 941 is your launcher. So that's your logical replication launcher. The first few messages are from the apply worker. By that time, the apply worker has exited, and that message is being broadcasted by, basically emitted by the launcher. And yeah, so next slide, that's the same. Yeah, what you'll notice is the first column changes, 57, 58, 59, and the time changes. The other important information to note is that from the time when you have a conflict and the time when you have another apply worker start, in this case, and in case you notice, this is a different slide. So this slide, and this slide deliberately kept the same slides, the same formatting. I'll let you know why. But if you look at that time here, it's 9 seconds, and this was 4 seconds. So apply worker restarted in 5 seconds, and this is on my laptop where there is no latency. So it took 5 seconds. Now imagine the number of transactions that might have happened on the publisher during these 5 seconds, the kind of workload you might have there, and the number of transactions that we need to reprocess here. So some transactions would have to be resent, some transactions would have to be reprocessed by the output plugin or the vault sender. So it's not just about running or having an issue here. It's also significantly impacting your performance. The more conflicts you end up having, the more restarts there will be, the more transmission of that data will be required. So all the transactions that might have been sent over those 5 seconds would have to be retransmitted. So if you continuously have this, you have a problem. But look at the line numbers on the first column, 52, 57. The reason why I actually put out the same file and the same information is that in the server log on the standby, it will carry on emitting this message. It will go on forever. So the server Postgres does not resolve this conflict. And it's going to fill up your log files. So it will carry on emitting. What happens is that your apply worker, once it has an error, it exits with an error code. It's relaunched. The same transaction is being processed again. It runs into the same issue again. It exits again and is restarted again. So it's a cycle that's never ending. And it's a cycle that actually shows in the log file then. The update in the native replication, there is actually no strategy. There is no strategy. So the transaction that comes in after the change will have its change updated into the table. It ignores the timestamps, so it's not the last wins, it's not the current one wins. It will just update that data, whichever comes later. It might have happened in an earlier time on a publisher as compared to the change here, or it might have happened later. It's completely ignored. So there is no timestamp management here. There is no conflict resolution of any sort. Then you have a delete-delete conflict. And actually, delete-delete conflict, although leads to a consistent state on both servers, it actually is an issue. It actually is a conflict. Because if we expect the replication to work properly, how can we delete the same row on 2 different servers? We expect that that delete will get replicated across, right? So when I delete it on the publisher, it should get deleted on the standby, on the subscriber as well. So if I have a delete that's happened on the standby, on the publisher and on the subscriber, both have deleted their data independently, and that information gets replicated, there's actually nothing written in the log. So Postgres does not inform you that something has screwed up, that a transaction that should have only come once has come to 2 different nodes and has made those changes, because then you wouldn't actually know when that change happened. So although they arrived at the same state of data, when they arrived and how they arrived is not known. So to categorize the data conflicts, we can identify or put them into 4 different categories. You have the non-divergent conflicts, where the state of the data is consistent at the end. So you'll have the same data on both publisher and subscriber with a delete-delete conflict. So both deletes happened independently. You have an update-delete conflict. So an update happened and delete happened. What sequence doesn't matter, because if the update arrives later, it's not going to find that tuple. So it still end up going to have the same data on both sides. Then you have the divergent conflicts, where you can end up with different data on different nodes. So publisher and subscriber, or node 1 or node 2 could have different data. So if you have inserts on both, you can end up with primary key violation. Similarly with update. Which update do you want to honor? The first one or the second one, your local change or the remote one? Then you have the sequencing one. So whether you have an update and insert, if they arrive out of sequence, your update comes earlier. Say you have a more complex network with multiple active servers, there is a possibility that your update is routed through a different server earlier than the insert. Update is not going to find that tuple, and it's just going to completely get ignored. And the insert would come later through a different channel, and that is going to leave a different data behind. Similarly, a delete, insert and delete. What happens if a delete comes in first and an insert later? So you'll have a row that should not exist. So you have that possibility. And finally, you have phantom conflict, where the phantom conflict is while you're processing and applying those changes on the subscriber, you want to inform your replication slot on the publisher that I have made this change. I have applied this change. But what happens if you actually crash before informing the publisher? It's going to resend that transaction, and you're going to reapply that, and yeah, it can have any kind of issues. So at PG Edge, we're working on Spock. This is kind of the next phase for PG Logical and based off BDR2. It's open source, so no strings attached. It does solve pretty much all of those problems that we've discussed with logical replication. It does come with a conflict-free replicated data type. This is for numeric data types. Spock does have a few minor patches to the core server, and those are available in the public Git repository. And I think maybe it's 100 lines, 150 lines, probably less. So very minimal changes to the server core, and where it's essentially just plugging in a few minor attributes where we need them, or making changes to certain elements in Postgres. So it has a delta apply functionality, which basically is a conflict-free, conflict avoidance strategy. You'll never have a conflict with delta apply data types. The other option is, the second thing is that when it's going to apply an update or a delete, it's actually going to look up whether the relevant row or tuple is available, whether it can find it in its local data. So it's going to wait there. It does have conflict resolution, so it can resolve certain conflicts based on timestamps, based on strategies that we define. And it does have exception logs and resolution logs to let you know whether something that should not happen has happened, but it's going to provide you with ample details to be able to debug that and make sure that you can trace it down. So pretty much consistent state of database is ensured here. It does have commit ordering. We do have an implementation of a Lamport clock, which is kind of a logical clock that ensures sequencing of transactions. It does address phantom commit avoidance. That is through a state machine, pretty much, that we've implemented. It uses Snowflake sequences with an identifier, node identifier as part of it. And we do have DDL replication. So when you alter a column or you add a new table or you make changes, it does replicate that information. This is how delta apply works. So essentially, delta apply avoids conflicts by taking the old value and the new value of a column, taking the differential of that and applying that change. So if you look at node 1, it has a value of 300, and it wants to update it to 310. That's a delta of 10. On node 2, we're adding 5. So the new value is 305. But as that transaction gets replicated, the node 2 also has the same value, and node 1 will get the same value with the transaction going back to node 1. So both node 1 and node 2 will end up with 315. There is no conflict. It's a conflict-free replicated data type. We have what we prefer is last update wins. So we don't care about the first update. We don't like local change wins or remote change wins. What we're looking at is last update wins. So in this particular case, you see that once you start a transaction on one node and you do a transaction on the other node in the meantime, now you basically have a conflict here, and that conflict is then registered in a conflict table. In this particular case, you have a resolution because it all gets resolved to a consistent value on both nodes. So you you have a resolution which informs you that what has changed and the details. So data conflicts, we're capturing them in exception logs. So non-divergent conflicts, we have exception logs. For divergent conflicts, we have exception logs, and we have numeric fields which are handled through a delta apply. We have commit ordering, which ensures that we do not have sequencing issues from one origin. We do have the phantom conflicts is avoided because we're maintaining a progress state on the subscriber side to ensure and to understand where we are at in context of the publisher. So that problem, if we crash before actually informing the publisher, can never happen because we know what to discard on this side. And that's all. Thank you.
Okay, we do have a couple minutes for questions. Got any out there?
I think I just poured them.
Awesome. All right, guys. How about if we could give one more round of applause to Ahmed for coming in, giving us a presentation. Thank you.
Hello, everybody. Welcome to the Ask Me Anything Postgres edition. Today we have several highly knowledgeable Postgres individuals. You may or may not have heard of them, but I'm going to do introductions. Jimmy Angelakos, Mark Wong, Davram Guntas, Magnus Hagender, Christoph Pettis. I'm Stacy Hazler, and Mark asked me to host this, and I said, sure, that would be great. I thought I was hosting it with Mark, but he's paneling. It's okay. So basically, the Ask Me Anything is ask a question. If there's a particular person you want to answer it, specify that. Otherwise, one of them will volunteer an answer. So without further ado, who has a question for our distinguished panelists? Anybody? Come on, there's got to be a question. It's anything. It's anything. I mean, nominally Postgres related, but.
All right, so let's say, hypothetically, you have a fabulous new product that you would like to release, just hypothetically, and it's a search engine, and you want to get it into the hosting providers, the Crunchy Data, EDB, everybody who does hosted Postgres. What have I got to do, first of all, to get to them, and what do they want, and how do I position it? And you guys are all insiders in this industry. I'm not yet. Tell me what we should do.
Anybody want to answer that one?
I'll start, but anyone else? So the first thing you need to do is get users to complain. Have them open tickets, have them say, why in the world does your hosted product not support this incredible extension? We would spin up 500 new instances if it did. Generally, they respond mostly. That's generally the path that they'll support anything that's in the core distribution, of course, because that is. But for things like that are outside of that, it's pretty much user demand that drives that on the part of the hosting providers. So sign up all your friends for an AWS accounts and have them file tickets.
Anybody else want to opine? Okay. Next question.
So regarding extensions, David Wheeler's been doing a lot of work getting more GUCs into the system to make Postgres more expandable as far as where extensions go and where the control files go and whatnot. Does anyone here want to talk about future plans for the Postgres extension kind of ecosystem as that's going? Because not everyone's following those threads very closely.
Okay, well, what I do know from having talked with David is he's got the extension ecosystem summits going on. He's got a lot of very smart people working on it all. And stay tuned.
I can comment a little bit on the topic. I can't tell you the insider information on how development is going to progress, but I can tell you some adjacent things that I've noticed from my experience. So people don't want package managers for extensions because everyone's got their own way of deploying and administering Postgres. So adding another package manager on top of what they already have in their operating system or their Kubernetes setup will increase complexity. And I think the community has finally recognized this and have stopped pursuing alternative package managers just for extensions. On the other hand, the flexibility you get with a tool like, for example, pip in Python, right, where you just type in install this, And instead of going and compiling it, as it did in the past, it just finds the proper binary image for what you want and just installs it with no fuss. I think that would be great to have in Postgres, right? If you could type in install extension and it had some way to grab it from a local repository of compiled extensions or a trusted online repository, that would be a great direction to go in.
I can add a few other comments that today also what I've seen, I mean, this is a topic that's been around for a long time, right? How do we package and distribute the extensions? And unfortunately, what I think I've seen in most cases is like the people, if you are running on, Debian, Ubuntu, Red Hat, all these platforms where we have our community packages, then for the majority of the big and popular extensions, it's actually a solved problem, right? It's not a solved problem for the smaller extensions, but it's also not a solved problem for other platforms. And so far, as I've seen, none of the efforts to make this easier have even considered the fact that we have many, many users on platforms like Windows or Mac. They're just saying, no, we don't care about them. But they are the ones who actually have the big problem today. They are the ones who have the really big problem today. And I think any effort that does not take those into account is sort of doomed to just repeat the same problems that we already have in a lot of ways. I don't actually, do you know that, Jimmy? You mentioned pip as an example. Does that work on Windows? Well, like, will it find and install the binaries on Windows as well? Yeah. So that's a great, in other ways, also a good example of a model that's interesting to follow. The pip of today, not the old one where you had to download the entire internet to compile your simple module, which is unfortunately where a lot of these things are today. So I think that's the part that needs to be solved. I don't know how much people are actually working on it.
How many extensions are being compiled on Windows?
I wanted to add to what Jimmy said, which is there's this contradiction, I think, in a lot of thinking, because if you talk to people and say, well, what if Postgres had a package manager like pip? And you could just say pip install, PG vector or whatever you wanted. And the answer is, well, we don't want to find another tool. We don't want all these things. And then you talk about, say, okay, but what do you need? And by the time they're done, they've basically described a package manager. So there's this tension there, and I'm not 100% sure how to resolve it. But it would be nice if it worked. I guess pip is our, design center here, because pip does handle both binary installations and source installations, and building from source. It does a lot of these things. So I'm sympathetic to the argument that, do we really need to have yet another tool that we have to learn and maintain and, has versions and all this kind of stuff? Because, of course, one of the problems always is what versioning, packaging the package manager. On the other hand, when you look at the requirements list, they basically just want it to happen. Or what they really want is for the package, the current packagers to kill themselves supporting 5 billion installations, but that's their extensions. But that's never going to happen. So,
I think another interesting point to be in them would also be for such a tool, whether it becomes, one of the problems that I see in a lot of places is people go, well, yeah, there is, for Python in that case, there is pip, but we don't want to use that. We want to use the stuff that's packaged for our operating system, right? So a tool like this should also ideally be able to produce all the output that people like Devrim would need to easily use this tool to turn it into a package that can go into the Yum repositories installed through the normal means, like in a way that works across all of this, not just at the end of the line, but also to inject. So we could get these extensions into the Yum repo, into the apt repo as well, for the large number of people who actually, want that.
Actually, we have pgextend client right now, which acts like pip for Postgres, which can download, compile, and install an extension to Postgres.
But it acts like the old pip.
Yeah, the old pip, yeah. Yeah. But still, is it enough? I don't think so.
I'm trying to come up with the most diplomatic way of saying it. The build farm is kind of, if you've ever seen a Dr. Seuss book with the pile of stuff with the fishbowl at the top leaning, that's kind of the build farm. It's amazing it works at all. I think we may not want to destabilize it. That being said, okay, but less joke and more reality, giving a way for third parties to guidance, at least for third parties to do that kind of, to build their own build farm, like, you know, or test things on a wide variety of hardware. I think that makes perfect sense.
I'll just add an important comment about the build farm is the build farm is not sandboxed. It cannot be used to test untrusted code. Right? That is why only, like, the code before it gets to the build farm, it has to pass the Postgres committers team. Because if I can inject code into that process, I can run arbitrary code on people's build farm machines, and they don't like that. The difference here is, for example, we also have the CI suite for Postgres, right, which runs on Cirrus CI. That is sandboxed. That people can just, you know, you clone the GitHub repo, you can enable it on your own account kind of thing. But it has limited platforms, so it might solve part of your problem. You can use tools like that to build for 16 different versions of, you know, Ubuntu and Red Hat and Debian and things like that, but you cannot use it to build for anything other than x86 and ARM. I'm actually not even sure they have ARM. So, but yeah, one big problem with the build farm in doing things like that is it is not sandboxed.
Okay.
Hi, so just to add a few more details. So I think the build farm pretty much covers all the platforms. There was a time when I worked with the installers for about 7 years for Postgres. So there is an update manager. I'm not sure that's still there with the installers now, where you used to update a catalog on the Postgres website where you update all the installers, and then those were for, back in the days, it was for all supported platforms, which included Linux, but I think it's for Windows and Mac OS now. So maybe that's a platform that can be used to provide kind of alerts there. But I think the build farm should cover all what you're asking for, all the platforms, operating systems.
It's on.
So yeah, okay. I think that's all.
Okay. Any comments on that? Oh, I'll have them repeat then. Okay, you need to repeat because they couldn't hear it all. Loud. Where's the microphone?
Okay, so I was saying that installers used to have update managers. So there was a tool for update manager which used to provide, or at least had a catalog of all the installers, including extensions and everything. And that was specific for installers. So that was one place where you could have all the changes, everything there. I think, and then obviously I think the build farm pretty much covers all the architectures and operating systems. I'm not sure whether anything should be missed out. It's pretty extensive. So anybody should be just looking at the build farms for Postgres and see if there's something missing. Maybe that's an opportunity to add to the Postgres build farm and just share their system with the community.
I think in general, I think the build farm is doing a pretty good job of having platforms covered. Today, we've more recently been removing things like, you know, if you went to my presentation this morning, like the Tom's old HPPA RISC machine is eventually, he was not allowed to move it to the new house. So we de-supported it because it was probably the only machine running Postgres on HPPA, right? It was still useful. It was actually useful for us in different, but we didn't expect people were using it to run Postgres on. But, you know, really slow and weird machines can show you bugs that just won't, they will show up on our normal machines as well. Just, you know, it takes much longer to see them because they're timing based and stuff like that. But in general, we do sometimes have, there's been some discussions recently around AIX, where IBM realized they wanted us to support AIX after we removed it. Because they wanted us to support AIX for them, they didn't really have the resources to do it themselves, and now they're looking at putting AIX back onto the build farm and stuff like that. But again, the build farm is only for core Postgres. And the way that it's built now, and I'm not sure, like the entire way that it works, not just how it's implemented, but the idea behind it, doesn't really lend itself to using it. I mean, it's called a build farm, but it's really a test farm. And it's not a tool for, you know, building packages across platforms and stuff. And I don't think the way that it's designed would not be a good way to do that. We need something else to handle that part.
Next question.
Okay, so I'm going to ask a question which I did not ask in the morning to Magnus because I already asked 20 and I did not feel like I should ask the 21st. But now we have some time. So, and I think you did not cover it in your what's new presentation. So it's about max connection. So it's a painful topic for many people, me including, having several hundred production Postgres and everybody doing whatever they want. And the developers do not understand why they should not span like, you know, connection pools like 100 times free for each of the applications that run on one database. So for previous couple of versions, I heard repeatedly that we are working on improving the ability to handle more connections concurrently. I did not hear today, and also, again, it's kind of my practice in the past 2 years, I'm not clear about what else is problematic except for if they really run like 1,000 connections and each gets, we are not sure how many times work mem, then we are running off like Linux memory. So anybody can comment on this, like what's the current like plans, guidelines, and what I do not know about this.
Well, I mean, that's, who has 3 hours? I mean, first of all, yes, there are certainly things going into 18 as well to improve the situation, but there is nothing massive, nothing substantial. Like these are good improvements, but they're incremental. They're going to move the goalpost, but they're not taking them away or so in any shape or form. There is a large project that will take many years to complete in total that's looking at moving Postgres from a process to a thread-based model. That doesn't in itself solve this problem, right? It doesn't, but it opens opportunities for changing other things around. It's not even the having many connections is not even the main reason to want to do it. It's for other reasons. It'll open up other venues to do it. As you say, the whole way that we assign memory through workmem won't, like that doesn't change just because you're in a threaded model, but it does make this unpredictable. It's like that's not a cost if you have, you know, if you have 10,000 connections, as long as they're not active, it doesn't cost you anything, and then they go active and you run out of memory, right? So having like a smarter way to deal with that would be excellent. I am not aware of anyone actively working on that problem at this time. There are other things that related to the fact that just by having a huge max connections, even if you don't use it, like a bunch of data structures and stuff in the system gets bigger, and that has a problem. Again, I don't think anyone is actively working on a way to solve that, but there have been discussions of putting, equivalents of connection poolers or such into the system, or even without that, doing more like resource management of not trying like Postgres. If you have 1,000 connections, you run 1,000 queries, it's going to run all of them at once. It's going to do its very best to run all of them at once. But for best throughput, it would probably be smarter to not run all of them at once, right? But right now, Postgres does not have anything to handle that situation. And again, I'm not aware of anyone actively working on that, but I know a lot of people are aware of the problem. So hopefully somebody will at some point. And some of these things will get easier if we get, I'm going to say if rather than when. I think it's a when, but I'm going to say an if. If we get to a threaded model, it opens up for some of these things being easier. Some of them will just, they can be done regardless of that. It's just a matter of figuring out how to do it. Anyone else want to comment on that?
Yeah, just to touch on what Magnus mentioned, Postgres is a process-based model as opposed to threads. So when you open 5,000 connections, it's not even a Postgres problem that Postgres works slowly. It's an operating system problem. It's most probably your operating system can't deal with these 5,000 processes that you've now spawned, and it has to do process accounting for them. It has to do inter-process communication and all that. So it's not an easy problem to solve. Maybe QoS and deciding who gets priority to run the queries would be some way. The current workaround is to use PG Bouncer, use a bunch of PG Bouncers that have different numbers of connections assigned to them, and you can hack your way around it.
There's also things that Postgres can implement that I'm going to naively say are much easier than changing to a whole threading model. Yeah, as opposed to rewriting Postgres, that to better support poolers, because I'll make the provocative statement that there is absolutely no reason to ever set max connections over about 350. You should, because that it's very hard to build a server that can handle 350 more than that lighting up at the same time and not fall over. So the only reason to do that is you're basically implementing pooling inside of Postgres and just crossing your fingers that you don't overload the system. For example, a lightweight call to do user authentication that did not spin up an entire backend would be very helpful, because then the pooler, then you wouldn't have to have this, separate database, basically having to maintain authentication information in two places. Being able to change a connection, change the database and user of a connection, which I understand is harder than it sounds, so that you didn't have to have separate pools for each one of those connection pairs. That by itself would go a long way to solving the front end problem on Postgres, I think.
Slightly related, slightly unrelated. There is an extension in Postgres, which I don't remember the name. I've been trying to remember it. I think it's PG Renice or something. But anyway, you can renice some of your processes in Linux. So it means you can give PG priority. Okay, that's the extension name. So if you use PG priority, you can give priority to some of your queries, which, so they're not being run at once. They will run at once, but some of them will get higher priority. So you can solve some problems by using that extension. I'm not going to say use the extension, but you can.
And if you do, be really, 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 really careful with what you're doing. And if you are not 100% sure of what you're doing, do not use it. It is very easy to get priority inversion when you use that, which means that you are slowing down the slow process, the things you don't care about, but the things you care about are waiting for those to complete. And oops. So you need to really know what your queries are doing all the way through. If you know that, then yes, it can be helpful, but it is a very scary and risky tool.
Great. Thank you, everybody. That was very enlightening. Next question?
Oh, yep. I remember in Postgres 17, there were some improvements on index scans with some murmurings of eventually maybe working towards skip scan support and similar. And I went to Magnus's talk this morning and didn't hear anything particularly related to that in the Postgres 18, on deck for release. So I'm just wondering, is there still active work in that area, or things that maybe just didn't quite make the cut, or yeah, what's the current status of that, if anyone knows?
I believe there is still work going on being able to do skip scans. I don't think there is anything that's in the pipeline for 18 in these things that might happen over the next 2 months. But it's not something that has been given up on. People do know that it would be a very useful thing to have.
Thank you, Magnus. Next, questions?
I'm seeing mention of Postgres like more and more, right? It's growing. Do you see a corresponding increase in support from corporate organizations? Companies, well, let's say, just as an example, Amazon, AWS, right? They've adopted Postgres in a big way, right? And they have even their own, the Aurora enhancements and so on. Are you seeing support in terms of code contributions? Are you seeing support in terms of financial contributions to the foundation?
Thank you. Thank you for clarifying.
Yeah, to steal your word, I'm trying to be diplomatic in here. So in the past, there were, I don't want to give any name to any cloud companies, okay? So no name given in this context. So they were just using the code and doing nothing else. Nowadays, not nowadays, in the last few years, they have some Postgres people writing Postgres code, contributing to the code, plus contributing to the infrastructure as well, in a way, direct or indirectly. We have some VMs contributed by some companies over there, like this. So yes, it's not. I'm sure it could be much better. They are late, but they are not just the consumers in the last few years. Again, I'm trying to be diplomatic and polite as well.
I think that's a pretty good summary. Like you can see among the hyperclouds, certainly both AWS, I'll mention them, both AWS and Microsoft today are investing heavily in Postgres, and they're investing heavily in Postgres. That means not RDS, not Aurora, not Azure, Postgres. They're also investing in their own products, but both of those are, if you look at the largest groups of contributors to Postgres core today from corporate entities, I believe are Amazon, Microsoft, and EDB. Right? They're significantly above everybody else when it comes to they both Microsoft and Amazon have full-time teams that work on contributing to the open source version of Postgres. We're seeing a bunch of others. There's also a lot of people sitting underneath the hyperscalers, if you will, who sell managed Postgres services that are running on top, because they're usually running on top of one of the hyperscalers, right? Some of them do a lot of contributions to Postgres. Some of them don't do basically anything at all yet. But I think we are seeing a move in the direction that, once they get off the ground, they tend to realize now, probably by looking at the others, right, that there is value in engaging and contributing back to the community. And those that don't end up, not being the successful ones, if you will. But yeah, we're definitely seeing better now. As Devin said, 10 years ago, they were users of Postgres. Now they are part of Postgres.
Yeah, I'm basically going to echo what Magnus said, which was the reason I jokingly waved it away, is this has been a huge complaint of mine for a long time, was that there were people making tons of money off of Postgres and not really paying the license fee in the terms of, as Stacy puts it, in terms of giving back to the community. I will single out Microsoft for not being that way. They put a lot, they seem very committed, and especially coming from an organization with the traditions of Microsoft, that's meaningful. And Amazon also has been much more active in the Postgres community in the traditional way, and they're contributing code and patches that aren't just, we need this to make our lives at for RDS easier. There's one cloud provider that may be notable by their absence in what I'm going to say, which I will not name, which I would like to see do more of that. But there's serious corporate cultural problems there. And as Magnus said, I think if I'm going to look with not so much angry as disappointed at anyone right now, it's the second layer of lockdown hosted service providers who I just never see anything from them. The other group which I want to mention is that there are a lot of of commercial products now that put Postgres compatible in really big letters at the top. Sometimes all this means is they speak the libpq protocol. You know, they're not even begin to be SQL level compatible with Postgres. But I do have this feeling like if you're going to call yourself Postgres compatible, you need to be more involved in the community and not just free ride.
I would just add there, because that's one of the hilarious parts I find. There are numerous products who've been going as we're Postgres wire protocol compatible. And to me, that kind of tells me you're not really into Postgres, because the wire protocol is not one of the good parts of Postgres. Like, it's not terrible, but like the list of things that we would like to do there, but haven't done because it requires breaking compatibility, that's a long list. So particularly if you want to be in the fast-moving space or whatever, that's actually not the part that I would look for compatibility with. The SQL level, that's where the compatibility is interesting, and that's where those companies generally don't.
So a notable example of this thing that it's Postgres compatible was an announcement this year of an Amazon product called DSQL. That thing is not even SQL compatible, let alone Postgres compatible, right? It's missing basic database features like sequences and views. And they still called it Postgres compatible because they can get away with technically being compatible with the wire protocol. So, but I think the fact that all these companies go out of their way now to say that they're compatible with Postgres means that they recognize value in this de facto standard that Postgres is now becoming, I think, in the database world. And that's a good thing. Of course, don't expect any of the hyperscalers to ever prioritize Postgres over any other database, because for them it's just another thing in their stable.
Yeah, the new Amazon product, I have to say, I roll my eyes a little bit at it because it makes Postgres compatibility. And in fact, because we're an independent consultancy, we get asked a lot of questions. For a long time it was, well, we want to set up multi-master on Amazon Aurora, because they were Googling finding the MySQL Aurora and would actually argue with me over whether or not it's Postgres supported multi-master or not. And in this one, I had a similar conversation with a client who wanted to test it out, and they said, and there was this cycle of, it's Postgres compatible. I said, well, it's wire protocol compatible, but it says it's Postgres compatible. It finally came down to say, just point your application at it and let me know how it goes. And the answer was it got three statements in and then started breaking. So it's unfortunate. Personally, I think we should just put libpq under the MongoDB license, and it would solve the whole problem. Because they couldn't actually, because I think that's the reason, is that libpq is open source, so they could just use it.
I mean, isn't it similar too? I mean, Postgres is 100% Oracle compatible, right? We just need to move the TCP ports over. We're all on TCP.
Oh, wait, Jimmy.
Sorry, I forgot to mention while we're on the topic of Postgres compatibility, there's actually a community member, Meyer, that's compiling a Postgres compatibility list. It's up on GitHub if you look for it. And it has Postgres compatibility tests and compares various Postgres-based or Postgres-adjacent products to see how compatible they are with vanilla Postgres.
Just speaking from a community point of view, I have noticed as someone who organizes conferences that the larger corporations are stepping up with their sponsorship, having their employees appear and speak on non-proprietary things, which is encouraging and exciting, and also letting their staff take on volunteer roles in the community, which was not a thing before. You would look down the list of volunteers and not see those company names. Now it's like, oh, okay, that's kind of cool. And one of those changes is more people who are active in the community have been hired by these companies. And and it's like, well, I do this thing. And I do, my old job paid me to do it on my work time, and I'd like to keep doing that. And they're like, oh, okay, yeah, sure. And so we're seeing more of that. And as a community organizer, I'm happy about that part. I will leave the technical parts to them, but in terms of community involvement, getting more people in to do all the amazing things that the Postgres project can do if we have enough people. So that's been very encouraging and exciting. 10 years ago, not the case, but now we're seeing that, and it's a significant improvement. Questions?
Okay, this is, no, I don't. Not with these hips. So this is for my compatriots here. If the genie appeared and said you can have one Postgres feature with zero implementation complexity, so you don't have to worry about what it would do to the code base, what would you ask for?
One Postgres feature that I could get for free, right, and not worry about how it was implemented. I discussed this with some other community members here today. I would like easy multi-master. What do I mean by easy multi-master, right? A switch that I could throw that just magically lets you replicate any change from any node to any other node in accordance with all distributed systems rules, like conflict detection, conflict avoidance, serialization, anomaly avoidance, and so on. I would like that.
I make my own unicorns. It's tough. I think I wouldn't mind seeing the async IO stuff for free.
I would love to see a Postgres which doesn't require restart to make any changes.
Well, you've taken some of the good ones. I'll add the ability to do something similar to Oracle Flashback, like being able to query your database the way it used to look without the overhead of user space time travel, but just being able to access it. And similar in relation to that, the recovery, some of the recovery functionality that we see in, for example, Oracle. They are the market leader in this, after all, of being able to, recover parts of your database without stopping the rest of the database while you're working on those things.
So mine is actually quite modest. I would like major version upgrades to work the way minor version upgrades do. You take it down, install the binaries, and bring it back up again. Because even though that's a significant part of doing major version upgrades, is a significant part of PGX's business. Even so, I would like to see that. In part because one of the frustrations is there's so much interesting development work going on in in Postgres, and people don't take advantage of it because they don't want to pay for a major version upgrade in terms of time, downtime, and complexity and things like that. And it's always, you want to talk to clients or somebody like that and say, that problem is solved in version 17, and there's this awkward pause as they say, well, yeah, but we're on 14 and we're debating whether or not to upgrade. We have actually, there's at least one client, well, of course we'll not name, who, as far as I can tell, is physically incapable of upgrading because they cannot take the downtime necessary to bring back up, to do even a PG upgrade, style upgrade, or even a logical replication switchover.
Yeah, we have one client that's still on 8.2. Eventually.
16 terabyte data with a 16 terabyte database.
It's exciting.
They can't even use PG upgrades or so.
Questions? Anybody have their one thing they'd like to have?
What is your favorite editor or tool to write and run queries?
I'm going to give the easiest answer, PSQL. Just has an editor, built an editor, uses an external editor. So, yeah, why not?
I don't have a different answer.
Anybody have an answer that isn't that? Jimmy?
No, it is the correct answer. So what I would like to ask the audience really is what your major pain point is, some usability thing that's not letting you enjoy Postgres as much as you should. That's what we want to hear.
I'm sure there are people with opinions. Oh, come on.
So I use PSQL basically for everything. And I find that generally adequate, except when you go to the gigantic queries, you know, the 10,000 line queries or things like that, or the very, very complex queries, because it just, you're dealing with, you know, VI or something. It's not so great. I will say for a more GUI style editor, I use the one as part of the JetBrains suite because I've licensed that anyway. I find them all kind of equivalent, I have to say. You know, there are a lot of them out there, but I haven't found any GUI editor that I feel is like worlds better than any other one. So I'd say just, you know, use the one you're comfortable with. But whatever you do, if a consultant asks you to send a query plan, don't send it as CSV, because that's the standard output format for a lot of them.
Also, don't send it as a screenshot, please.
Yes, I'm going to jump in and totally break protocol and say, please, nobody send screenshots anymore. That just swear on a stack of whatever you wish to that you'll send it as text that can be edited, because it's frustrating.
Well, if they ask, but don't just automatically send.
Yeah. For example, Dalibo's query explain analyze tool is great. It's very pretty. I love it. But if we ask for an explain for the output of explain analyze, do not send the output of a screenshot of the output of the Dalibo tool that's half cut off. Not that I'm bitter or anything, but
not that anyone ever did.
Yeah, that never happens. That never happens. Anyway, back to Jimmy's question. What are your pain points? Or there are none? What? Yeah, no. we have 5 minutes. Yeah, 5 minutes, pick your biggest one.
Oh, well.
One.
Oh, I only get one?
We only have 5 minutes, fine.
Okay, I would like to see a much simpler table access method, because I just can't penetrate this thing. And I would like to be able to do my own table access method before my rapidly diminishing youth is completely gone. And in part two of just one thing, I would love to see multiple, the Postgres wire protocol return multiple result sets instead of having to deal with cursors or whatever other, or unions or whatever kind of other games you got to play to make this work. Every other database does this. I'll have more.
I'll comment on the first one by saying good luck with that. I think most other people are complaining that it's too simple to actually solve the problem. Like they're too limited, the table access methods, that the API is too limited to solve certain things. But more to the other point, look into libpq pipelining, because I believe libpq has pipelining, query pipelining, so the wire protocol can send multiple result sets. And with libpq pipelining, you can access it through the driver. So I think you actually already have what you're looking for. It's just well hidden.
XID wraparound. I want less of that, obviously. Less. Get rid of it. Break it out.
Six.
4 billion transactions is a lot. You'll be fine.
Yeah.
Actually, it's only 2 billion. Yeah, 2 billion.
So I'm going to ask a reverse question. If you were able to set the XID size on a NitDB, which means that for your, hypothetically, which means, so you could pick either 32 bits with, so you either get the, so it's controllable whether you pay the extra 8 bytes per record on for it. And this means there would be no clean migration path. It's not basically a dump restore. How would you feel about that?
The reason I brought that up is because I've written several blogs about this, even at EDB. And the true question behind all of this, like you implied, is changing the file format. And it also goes with your other customer that has problems with doing major upgrades. The true solution is, at least right now, to do a database migration to a logical migration, some kind of thing where you're transferring your data over the wire to some predefined system that is pre-migrated to the new file format or whatever that will solve that problem. And maybe even to address your earlier implication that your customer couldn't have a zero downtime upgrade, EDB has a tool called EnterpriseDB Distributed that can do multi-version compatibility. So you could have a 16 version, upgrade a node to 17 or 18, and then rolling upgrade that throughout your entire cluster. But you'd have to be on EDB Postgres Distributed for that to work. But yeah, I know that requires a binary level change to Postgres, but we need to do it before it's impossible to do it all, or extend the TAM API so that we can bolt on our own storage methods to make it so that's not a problem.
Yeah, I mean, well, here's the thing. The way MVCC works is you've stored these transaction IDs actually in the record itself, which costs another 24 bytes, which is very inefficient. And if we had a simpler table access method, we could devise our own way of solving this problem, like having TIDs that were truly 64 bits and opaque, and doing all sorts of really interesting things with different ways of doing MVCC, or not doing it all if you've got an analytics application, but it's just too hard to do right now.
There's this, if you will pardon the expression, elephant in the room about Postgres, which is right now which is we have PG upgrade, which is a heroic. You know, I can remember when there was a PG upgrade, and it's kind of amazing that, you know, Bruce sat down and said, I don't care how hard this is, I'm going to do it. And then we got PG migrator. Yeah. So, but the problem is we're stuck with the file format. Is that it has to be that for PG upgrade to work, the data files have to be binary compatible with version to version. You know, in an upwards compatible way, not necessarily downwards, and that is a limit, and that's a limit that's going to ultimately at some point we're going to have to figure out what happens when we want to change something like make XIDs bigger as an example that is not upwards compatible, because the installations out there with 32 terabyte databases are not going to be doing dump restores. So that's an interesting question of what we do there. Do we version stamp records? You know, which is a good, you know, I wouldn't say that at dev because I get killed. But do we start doing versioning on the system catalogs, which would allow in-place major version upgrade? But you know, because right now development takes full advantage of the fact that we can just, you know, break the system catalogs in any way we can, and, you know, screw up everyone's monitoring tools version to version. So, but at some point that's going to that problem is going to have to be wrestled with, and I don't have any great ideas.
Sorry, yeah, we have a command line tool that can convert your database from non-checksum to checksum, right? Like, assuming we got the Summit compatible format, you could shut down your database, run the tool over it so that it's a higher bit depth or whatever, so that you have more XID room or whatever the solution ends up being.
The problem in general with those is that has been looked at, right? The problem comes up when you add checksums. It doesn't add any data. The checksums are there in your database when there are no checksums. They're just all 0, right? If you go in the example of going from 32 to 64-bit XID, you change the size of the data, which means it may no longer fit on what fit on one page before no longer fits on one page. And that's where the problem comes in. Now, technically, like there have been talks of ways of working. Like you could, for example, require people to have free space. You can actually do that by saying, before you do this upgrade, you have to first do a minor upgrade to this version, and then run for 6 months or whatever, and have a very slow vacuum that clears out, so you have, you know, 8 bytes extra free on every page in your database. Like, it's kind of a painful process, but these are doable things. We would find a slightly better process than just that, but like there are ways to get through that, but to require steps on the way. And I think in the end, to get around it, like, because yeah, we're gonna have to get around it at some point. Like, that's not gonna remain optional. We've gotten a lot of mileage out of the current format. There are a few bits left and some bytes here and there that can still be used in this current format, but like we will have to do it. It's similar. There is a long list of things we want to do there, just like we had with the LibPQ protocol. Like, there are a lot of things that we want to do that cannot be done without at some point doing a hard break. And at some point we're getting to the point where we're going to have to do that hard break and just try to make it as, you know, non-painful as possible to get there. For now, we're, you know, pushing it ahead of us and kind of it's mostly working to do that. And then, of course, once we've solved that, then we can go into the bike shedding of whether we actually want 64-bit XIDs or not. Because there are other solutions to that problem that might actually be, you know, more attractive, but they will have the same fundamental problem of handling the upgrades.
Well, we can't change the libpq protocol because we'd break Snowflake. You know, since it depends on the libpq.
Let me go change it.
All right, everybody. We, believe it or not, have filled our entire time slot. So thank you very much for coming. Thank you for your excellent questions.
if when the expo hall opens, there'll be a Postgres booth in there, so some of us will still be around if you want to catch us later, ask some other questions, take some selfies, whatnot. Please stop by.
And by the way, thank you for using Postgres. Yes, I'd like to. It's about the users, and I wanted to make sure that everyone feels appreciated that you're using this database. Anyway, so we just put PG time back in, and you have your time travel. That was pulled out because it was a horrible performance sync, but I'm sure we could fix that.
Magnus, I haven't seen that expression on your face many times, and I've known you for decades now, so... Anyway, thank you for coming. Thank you for your questions. As Mark said, there'll be a community booth in the expo hall. You can stop by, chat about Postgres, ask more questions, get autographs. And also, don't forget, there are the mailing lists on postgresql.org. All kinds of questions, all kinds of discussions. Keep it civil. And again, thank you so much. Have a lovely evening. We'll do some more Postgres things tomorrow. Good night.